Hello, scientific writers. Welcome to the Expert Scientific Writing Techniques course. I'm your instructor, Dr. Brian Waters. I think you're going to enjoy this one. I really like scientific writing, and I really like thinking about how to make sentences and paragraphs better. And by better, I mean more concise, more consistent, more coherent, making them flow well, looking for cohesion, all of these kinds of things that makes good scientific writing at the sentence and paragraph level. So let's get started on this course. This is the first lesson, which is basically an introduction to the course. So I would like to start with some recent headlines from the scientific press. For example, I have a headline here from Nature News. This headline says, "Science is getting harder to read." This was from September 2020. The subheading here, "From obscure acronyms to unnecessary jargon, research papers are increasingly impenetrable, even for scientists." And I have a little excerpt from the paper down below. "Science is becoming more difficult to understand due to the sheer number of acronyms, long sentences, and impenetrable jargon in academic writing. Not only does such overcomplicated language alienate non-scientists and the media, it can also make life difficult for junior researchers and those transitioning to new fields." Scientific writing is often talked about as bad writing. It doesn't have to be, and there's a lot of really good scientific writing out there, but there's also a lot of bad scientific writing. And so this headline is telling us that the bad scientific writing is becoming more and more commonplace. It's becoming more prevalent. And so we're going to look at ways that you can make your scientific writing fall on the good side, not on the bad side. This is a quote that I really like. This is from Steven Pinker. And he says, "Why should a profession that trades in words and dedicates itself to the transmission of knowledge so often turn out prose that is turgid, soggy, wooden, bloated, clumsy, obscure, unpleasant to read, and impossible to understand?" Well, that's a great question, Dr. Pinker. Why do we turn out that kind of prose? In his book, he talks a lot about the reasons why. And I think the more important thing is not really understanding why. In this course, I'm going to tell you how to not do that. How to turn out prose that is clear, crisp, lively, concise, smooth, unambiguous, pleasant to read, and easy to understand. That's the place I want to get you to after taking this course. So why does it matter? Why don't we just publish our work or submit our grant proposals and, let the readers worry about interpreting it and figuring out what we're trying to say? Why should you try to make your work clear, crisp, concise, pleasant to read, all of that we just talked about? So let's talk about some reasons why. Well, here's another quote I would like to show you from Dr. Randy Olson in his book called "Houston, We Have a Narrative." And he says, "Poor communicators are able to say the same basic things as good communicators. They just need a lot more time and space in which to do it, which ends up boring everyone." Let's look at some more headlines. In the New York Times, they highlighted this article that was published in the Proceedings of the Royal Society, Section B, Biological Sciences. And this was from April 2021. The New York Times headline says, "Are you confused by scientific jargon? So are scientists. Scientific papers containing lots of specialized terminology are less likely to be cited by other researchers." And so this New York Times article is about the journal article, which we see the title below here. It says, "Specialized terminology reduces the number of citations of scientific papers." So some scientists actually did a study on this topic, looking at characteristics for what makes papers cited more or cited less. And they found that using a lot of jargon and fancy words that are hard to understand decreases citations. So if your papers are being cited less, they're having less of an impact in the world, in your field, and in society. And if you're writing a grant proposal and you're using terminology that's hard to understand, the reviewers are less likely to get excited about your proposal and support it in the panel session where the decisions are made. Let's look at another headline. This is a press release from the Columbia Business School. Researchers there that did a study, and they found that people who lack status are more likely to use jargon to compensate for their insecurities. And I've highlighted a quote here. It says, "Jargon is like a suit, a car, or a watch. It's a status symbol. Those who are insecure dress up their words, believing it will make them appear smarter or cause others to take them more seriously." However, they found that people that are secure in their high status actually use less jargon, fewer acronyms, and less legalese. In this case, we could say scientific ease in our case. And these high status people prioritize clear communication rather than concerning themselves with status or public perception. Another headline. This is from the Association for Psychological Science. Alienating the audience, how abbreviations hamper scientific communication. It says abbreviations are mentally taxing on a reader and can incidentally alienate an audience. By simply replacing abbreviations with the words that they stand for, we greatly improve our communication. The authors go on to say, let's consider making our writing more open and easily accessible. Yeah, that's important if you want your work to have impact. Here's another one. This is also from 2017. The readability of scientific texts is decreasing over time. They looked at over 700,000 abstracts published from 1881 until 2015 in 123 different scientific journals. And they measured the readability of these articles. And they found that readability has been decreasing over time. They say that these results are concerning for scientists and for the wider public, as they impact both the reproducibility and accessibility of research findings. So again, if people can't read your work, if it's too much work for them, they're just going to throw it aside. They're not going to finish reading it. If they don't finish reading it, they're less likely to cite your work, they're less likely to fund your grant application, and your work is not going to have the impact that it could otherwise. So it's really important to make your writing easy for the reader. That's my top priority when I'm a writer, is to make it easy for my reader to understand what I'm saying and to make it easy for them to read quickly through my sentences, through my paragraphs. All right, one more headline for you. This is from Science. And this was from April 2021. And they say, do you want other scientists to cite you? Then drop the jargon. Okay, so we're looking at this jargon study again that the New York Times talked about. This coverage of it highlights a few different things that I just wanted to show you some quotes from this article. So at the beginning of his career, Alejandro Martinez peppered his papers with fancy words, he says, because that's what others in his field did, and he thought it would impress his colleagues. But he continued, his work wasn't getting cited. I was really not getting the impact that I was expecting, he says. And he has since changed course and now makes a point of framing his research so that it will interest a broader audience. A strategy that forces him to cut down on jargon. And so now his papers are getting cited more because he's writing them in a more accessible way that's more reader friendly. So I think these headlines give you some answers to the question, why does it matter? Why bother making your writing readable? Number one, so you don't bore your readers. Number two, so you don't confuse your readers. Number three, so you don't appear insecure. Fourthly, so you don't alienate readers and limit your audience. And together, these points are going to increase the impact of your work if you write it more clearly. And that will also decrease your rejection rate. And the flip side of that is increasing your acceptance rate. So I think those are all positive benefits of making the effort to make your writing better. All right, here's a quote from William Llewellyn. He was a journal editor for many years. And in one of his advice columns, he says this: I do not believe it is possible for one person to teach another person how to write. All right, so you might be scratching your head and saying, if that's the case, why are we doing a scientific writing course? Brian, if you can't teach me how to write, why am I taking your course? Well, this is not the entire quote. There's a little bit more that I didn't show you yet. So let's take a look at the rest of it. One person can teach another about writing, but the only way to learn how to write is to write. Now, the reason I'm showing you this is because I want you to be aware of this fact that you have to put in the work to learn this material. I can show you examples. You can understand those examples. I can tell you all kinds of things, and you can say, yeah, that makes sense. But if you don't go out and put it into practice, it's not going to stick. So I'm going to teach you about all of these writing techniques, but it's when you start putting them into practice that you will learn those techniques. So let's look at this writing improvement cycle. If you took my course on how to write your scientific journal article, then you've seen this slide before. I came up with this concept after teaching scientific writing at the university level for several semesters. And I was really reflecting on how students were learning scientific writing. And this is what I came up with. It starts with awareness. The awareness is put into practice, and then you get feedback on your practice, which gives you additional awareness. And then you do more practice, get more feedback. And this is a cycle that's a virtuous cycle. It's going to improve your abilities every time you go through this cycle. And so in this course, what I'm going to give you is the awareness part of the equation. It's up to you to do the practice and then to find some feedback. So you can get feedback from your lab mates, your colleagues at work, or you can hire a consultant that will give you feedback. And you can get feedback yourself, because once you've gained awareness, then you can evaluate your own writing using the principles that we talk about. And so this writing improvement cycle applies to reading, it applies to writing, and it applies to editing. All of these parts of the writing process are going to be improved as you gain awareness and put it into practice. Now, let me talk about my goal as an instructor. My goal is to help you write your scientific text in the most readable, clear, and concise way possible. Breaking that goal down into objectives. First, I want to help you become aware of good scientific writing at the sentence and paragraph levels. That's what this course is about. I'm going to provide you with specific examples to illustrate good scientific writing and not so good scientific writing. These examples are going to come from the literature. They're going to be real examples. Sometimes there are sentences that I just verbatim put into the slides that I'm going to show you. Sometimes I've edited them so that they're not identifiable, or that they're shorter so that the mistake shows up more clearly. And sometimes I took a good sentence and made it into a bad sentence by intentionally making mistakes for the purposes of illustrating those mistakes. All right, objective number 3. I will help you know how to give a paper a high degree of readability. And objective 4 is, overall, I want you to help you become a better scientific writer and thinker. Writing and thinking go hand in hand. You can't write without thinking, and as you write, you're going to refine your thinking. So this is another kind of cycle. The thinking is some of that feedback I was talking about in the writing improvement cycle. Let's take a look at the course structure. So this course is going to be in 8 different lessons. We're in lesson 1 right now, the introduction to the course. Lesson number 2 is coherent sentences in the English language. In this lesson, we're going to review parts of speech and some basic grammar that you need to bring up to the forefront of your mind. You've probably learned it before, but we'll look at it one more time. Lesson number 3 is Technical Writing Fundamentals. So the title of this lesson is Technical Writing. What's it all about? So we're going to step back and look at scientific writing as a subgenre of technical writing. Lesson 4 is readability. How do you define readability and how do you achieve it? Lesson 5 is on structuring your sentences and paragraphs for impact. Lesson number 6 is on word choice. So this is words and punctuation with a punch. So how to make your writing really impactful and powerful. Lesson number 7 is keep your reader by writing with clarity. The opposite of that is if you're writing without clarity, your reader is going to put your paper down or put your grant proposal down and stop reading it. And we don't want that. We want to keep the reader. And lesson number 8, keep your reader awake and alert by being concise. So that's what this course is going to look like. So each lesson is going to have a video component. And in this video, I'm going to show you a lot of real examples. But then I'm also going to have some worksheets for you where you can work on real examples of scientific writing. And each lesson will also have a quiz. So if you pass all the quizzes, then you will have completed the course successfully and you will earn a certificate. Now let's talk about how to do well in this course. The first one's pretty obvious. Do all of the lessons. But the important part there is to practice. So don't just watch the videos. Get out the worksheets, work on those. And then after you've done the worksheet and you've done the quiz, practice. Now how do you do that? Grab your stack of papers and start looking at them. Look for good sentences. Look for mistakes that writers might be making. So that goes along with point number 2, to think and reflect. So we're not just going to do the lessons and move on, but you need to really start thinking about how can I recognize these mistakes? Why are they being made? And how can I avoid them in my writing or correct them in my writing? Item number 3, put effort into implementing the lessons. So effort is important. I emphasized that earlier. I'd like to reiterate it here again. Write every day. I really recommend having a daily writing practice. I think that's an important thing of being a prolific and productive scientific writer is to have a daily practice. Build it into a habit. Take your time with the lessons. So I don't want you to sit down and watch everything in one day. You need to do it week by week and really develop your skills with each lesson before you move on to the next lesson. And finally, I want you to have fun. For me, this is the most fun part of scientific writing is the revising and editing and making my sentences and paragraphs look really nice. That's what I love to do. So have fun with it. If you can't have fun, then I'd say at least enjoy the challenge. So that's the introduction to the course. I think you're going to enjoy it. I know I will. So you're ready to move on to the next lesson. And in the meantime, happy writing. Hello, scientific writers. Welcome to lesson 2. This lesson is on coherent sentences in the English language. So what we're going to do in this lesson is we're going to look at some basics of English language grammar. I don't need you to memorize all of this information. Most of it you have probably learned before, but I want to bring it back to the front of your mind because when we look in the later lessons at specific mistakes, if you have the grammar in mind, it's going to make it easier for you to understand why those specific mistakes are mistakes, and it's going to make it easier for you to understand how to fix them. There's a lot of terms that we'll talk about, but again, I don't expect you to memorize or remember all of these terms, but I want you to understand the way that these concepts function, how they work in a sentence, and that's going to help us in the later lessons. So let's first take a look at the learning outcomes for this lesson. After you complete this lesson, you will be able to list and define the parts of speech. You'll be able to classify words of a sentence into parts of speech. You'll be able to identify the subject of a sentence and the main verb of a sentence, as well as the other verbs in a sentence. You'll be able to explain when to use past tense, present tense, or future tense. You will be able to use singular and plural nouns and verbs appropriately. You will be able to define the passive voice and the active voice, and you'll know when to use the passive voice and when to use the active voice. Similarly, you'll be able to define the first, second, and third person point of view, and you'll know which ones you should use in your scientific writing. So let's get started. The outline of this lesson is shown here. First, we're going to talk about the 8 parts of speech. Then we will look at sentence structure. We'll look at tenses, at articles, at plurals. Then finally, we'll look at active voice and passive voice and first, second, and third person. Okay, let's get going with the 8 parts of speech. You see the 8 parts of speech listed here. These are verb, noun, pronoun, adjective, adverb, preposition, conjugation, and interjection. Again, it's not that important that you memorize all of these terms. You can always come back to this lesson or glance at your notes. But I'm going to go through each of these parts of speech and talk about their functions and how they work in an English language sentence. All right, the first part of speech that we need to look at is a verb. So verbs are very important in the English language. They are what gives a sentence its action, if it has action, or they talk about the state of being. A verb is necessary for a complete sentence. If you have a set of words and it doesn't have a verb in it, it cannot be a sentence. So that's an important thing to keep in mind for English. So let's look at some example sentences here. Brian writes every day. So writes here is an action verb. It's showing action. So I'm writing, typing on my laptop. Brian is a teacher. So it's talking about me. I am a teacher. So this is a state of being. It's telling what I am. I am a teacher. Now here's another sentence. Brian felt cold during the winter. So felt is a verb here, and it's talking about my experience. So my experience of feeling cold. Well, let's look at some more examples in scientific sentences. Okay, here's the first one, and I have all of the verbs highlighted in the blue color. So the first sentence says, expression studies highlighted important differences in response to iron deficiency between soybean and model species. So here the verb is highlighted. The studies highlighted the differences. The second sentence, soybean is an agronomically important crop originally domesticated in China in 1100 BC. So we have a state of being verb, is, and we have a second verb in this sentence, domesticated. So the domesticated is more of an action verb. And then the third example of a verb is, we conducted more in-depth phenotyping to identify the first time point during grain development in which differences in grain length are established between P1 nils. So the first verb, conducted, is the main verb in the sentence, and it's an action verb. The second verb in the sentence, are, is a state of being verb. Okay, let's look at nouns. Nouns are a person, place, thing, living thing or not living thing, a feeling or an idea or a concept. So they cover a lot of ground. Let's look at some examples. And in each of these examples, I have highlighted the nouns in red. Expression studies highlighted important differences in response to iron deficiency between soybean and model species. So you see 5 different nouns in that example. Second sentence, soybean is an agronomically important crop originally domesticated in China in 1100 BC. So these are the same sentences we saw with the verbs, but now we're looking at the nouns in the sentences. We don't see a person in any of these sentences. We do see a place, China, and we do see some things, soybean, crop, and we do see some ideas like deficiency and differences. We also see a time, 1100 BC. This is also a noun. Now going along with nouns, we have pronouns. Pronouns are parts of speech that take the place of a noun in a sentence, and they do that to avoid repetition. So examples of pronouns are I, you, we, they, he, she, me, you, us, them, him, her, it. And there can be other pronouns, but those are some examples. So let's look at how they are used in 2 different examples. Firstly, we have this sentence. Since sorghum grains are important as food, Numerous studies have been conducted on traits related to grain weight, and more than 100 quantitative trait loci for it have been identified. So you see there in the bold in green, first I have the noun, grain weight, and then I have a pronoun, it. So the it refers to grain weight. So what they could have done in this sentence is say, numerous studies have been conducted on traits related to grain weight, and more than 100 quantitative trait loci for grain weight have been identified. But that is repetitive, it's kind of redundant, and it feels weird to say it that way. So we just use a pronoun. It makes the sentence faster to read and smoother, and you understand what the it is referring to. The second example is we also identified transcription factors within our data set to observe how they correlate with gene expression in response to iron stress. So they is standing in for transcription factors. The noun is transcription factors, the pronoun is they. So again, the authors could have written it this way. We also identified transcription factors within our data set to observe how transcription factors correlate with gene expression in response to iron stress. But that's awkward and repetitive. So the pronoun is a good way to solve that repetitive problem. Next, we have adjectives. What are adjectives? These are descriptive words. They provide information about a noun or a pronoun. And the adjectives include articles like a, an, and the. Adjectives answer questions such as what size, what color, what type, etc. So they answer questions of what. So if you take your noun and you ask what about that noun, an adjective is going to answer it. Let's look at some examples here. Expression studies highlighted important differences in response to iron deficiency between soybean and model species. So the bolded gold-colored words are the adjectives here. So we could just say studies highlighted differences in response to deficiency between soybean and species. But you'd say, well, what studies? What studies highlighted differences? Expression studies. And what about these differences? Important differences. The authors are focused on important differences, not unimportant differences. What kind of deficiency? Iron deficiency. What kind of species? Model species. So you see how the adjectives are answering that what question. Here's another example. Soybean is an agronomically important crop, originally domesticated in China in 1100 BC. So we could just write soybean is a crop, but that's obvious. So you would ask, what's important about soybean as a crop? So it's important agronomically. Those are two adjectives. It's agronomically important crop. Okay, now let's look at adverbs. Adverbs are kind of like adjectives in that they provide additional information about verbs. It's mostly about verbs, but they can also provide information about adjectives and other adverbs. So adverbs answer questions when or how. So we saw before that adjectives answer questions of what. Adverbs answer questions of when or how. Let's look at some examples. A supplemental nutrient solution was added daily to maintain proper plant nutrition. So which of these words that are colored and bolded here are the verb? Was added is the verb. So what's the adverb? It's daily. So daily is providing more information about when the nutrient solution was added. It was added daily. Plant tissues were flash frozen in liquid nitrogen and stored in a minus 80 degrees C freezer. So what is the verb here? Frozen. How was it frozen? Flash frozen. So flash is an adverb to frozen. It describes how it was frozen. It was flash frozen, which means it was frozen very quickly, as quickly as possible. A third example is shown here. Soybean is an agronomically important crop, originally domesticated in China in 1100 BC. So the verb here is domesticated, and the adverb is originally. Let's look at prepositions. So the key to remembering what a preposition is to break this word down. Preposition. It's pre-telling you the position of something that's in this sentence. So prepositions are words that provide information about relationships in time, place, or position. They're linkers. They usually connect noun phrases to another part of a sentence. So some examples of prepositions are in, into, than, like, through, above, below, over, under, outside, within, on, at, by, from, with, before, after, for, during, about, out, of, to, up. Now this is not a complete list. It's just some examples of prepositions. Let's look at how they're used in some example sentences. Plant tissues were frozen in liquid nitrogen and stored in a minus 80 degrees C freezer until RNA was isolated. So we see plant tissues were flash frozen. That could be a complete sentence, but you want some more information about it. So they were flash frozen in liquid nitrogen, and they were stored how? In a minus 80 freezer. And they were stored for how long? Until RNA was isolated. So you see how these prepositions are providing more information by linking to that additional information about the flash frozen tissues. A second example is this one. We established and reported a sorghum recombinant inbred line derived from a parental cross between BTX 623 and the Japanese landrace Nog. So we have the RAL line, and it's derived from a parental cross between these other two lines. Okay, so those are our prepositions linking these noun phrases that provide additional information about the main topic of the sentence. Okay, the next part of speech is the conjunction. So what are conjunctions? Well, the function of a conjunction is to connect ideas in space and time. Okay, so it's a little bit like a preposition, but a little bit different. Some examples of conjunctions are for, and, but, or, yet, so, because, either or, before, after, during, while, until, whereas. A couple examples here we have, since sorghum grains are important as food, numerous studies have been conducted on traits related to grain weight, and more than 100 quantitative trait loci for it have been identified. So two conjunctions here. One of them is since. Now you could take that since phrase and you could move it after grain weight. It could say something like this. Numerous studies have been conducted on traits related to grain weight since sorghum grains are important as food. Right? So it's telling you why they're doing something. So since is our conjunction. And then we have and, that's joining these two parts of the sentences. Okay, let's look at one more example. DEGs in cluster TL1 were induced in response to iron stress at 2 days, but had mixed expression at 10 days. So this conjunction is connecting these two different ideas. They had induced expression at one point in time, but they had different expression at a different point. So they're two different ideas. They're being connected by this but word. The last part of speech is the interjection, and this shows sudden emotion or exclamation. They will probably not be used in scientific writing. All right, we have covered the 8 parts of speech. I hope all of that made sense to you and that you understand how all of those parts function. That's more important than remembering the names for the parts of speech, is really understanding how they work together in a sentence to provide information to the reader and to structure a sentence in a coherent way. And I only gave you a few examples of those. You'll have more examples on your worksheets and on the quiz, but what I would like you to do is look for examples on your own in the scientific papers that you are reading, or even in the sentences that you have written yourself. Next, we're going to look at sentence structure. So in English, there are 4 functional categories of sentences. We can classify them into declarative, interrogative, imperative, and exclamatory. Now let's start with the last one, exclamatory. We already looked at the interjection as a part of speech, and that goes along with an exclamatory sentence. It expresses strong emotion. We're not going to use those in scientific writing. So back to the top, a declarative sentence is a sentence that makes a statement. It declares something. An interrogative sentence asks a question, right? It's interrogating the reader in a way. You could think of it that way. It's going to ask a question. And an imperative sentence is going to give a command. It's going to make a request, or it's going to give instructions. So which of these sentences do you think is going to be the most common in scientific writing? I hope you said declarative. So a declarative sentence is going to definitely be the most common type of sentence in scientific writing. Occasionally you might see an interrogative sentence, a question sentence, and maybe in materials and methods or some scientific writing you might give some instructions, but that's going to be not very often either. So declarative sentences are going to make up the vast majority of sentences in scientific writing. So what is a sentence anyway? How do we define a sentence? Well, first it must have a subject. The subject is what the sentence is about. It is the person, place, thing, or idea. In other words, it contains a noun. It can be a single word, it can be a single word noun, or it can be a phrase. Another thing that a sentence must have is it must have what we call a predicate. So there's a subject and a predicate. Now the predicate has to have a verb. As we mentioned when we talked about the parts of speech, you have to have a verb to have a sentence. So the verb is what the person, place, thing, or idea is doing, or its condition. And so the predicate describes all of that, and it includes the verb. The third thing about a sentence is it must be a complete thought. It must have a complete thought or a complete idea, or it's not a complete sentence. It's a partial sentence. And we'll talk about partial sentences later. And one thing that's really important to remember is that in English, the subject comes before the verb. The subject comes first, and then the predicate, and the verb is inside that predicate. Now, when we have certain types of questions, this is reversed. The verb might come before the subject. But in declarative sentences, which are, again, the vast majority of the sentences you will write for scientific writing, the subject comes first, the verb comes after the subject. Let's look at some examples of sentences. And we'll look at the subject, which is in red, and the predicate, which is in italics that are underlined, and then the verb is in blue. So this first sentence says, a supplemental nutrient solution was added daily to maintain proper plant nutrition. The subject is a supplemental nutrient solution. That's what the sentence is about. It's about a supplemental nutrient solution. The predicate is all the rest of the sentence. Was added daily to maintain proper plant nutrition. The verb in that predicate is was added. Second example, soybean is an agronomically important crop. The subject is soybean. The predicate is an agronomically important crop. The verb there is a state of being verb. It's is. Okay, so soybean is an agronomically important crop. That's a full sentence. It has the subject, it has a predicate, and it's a complete thought. Even though it's short, it's a complete sentence. Okay, next, recent advantages in targeted genome sequencing are revolutionizing biological research. So the subject is recent advances in targeted genome sequencing. And this is another state of being verb, are, and then you see the rest of the sentence is included in that predicate. And then a final example says, recent advances enable mRNA-seq analysis of individual cells. Now, this one is a little bit different than the third example because they don't specify what kind of recent advances. But recent advances is the subject of the sentence again, and enable is the verb. So this is an action verb. And the predicate is enable mRNA-seq analysis of individual cells. Let's continue talking about what makes a sentence. And we're going to have a couple more vocabulary terms for you here. The first is a phrase. A phrase is a group of words that act as a part of a sentence, but it does not have a subject and verb. Whereas a clause is a group of words that's part of a sentence that contain a subject and a verb. So a clause has both a subject and a verb, whereas a phrase does not have both a subject and a verb. It might have some nouns, it might have a verb, but it doesn't have both a subject and a verb. Now, a type of clause called an independent clause is required in a sentence. An independent clause is a clause that can stand on its own as a sentence. A complete sentence must include an independent clause, and an independent clause might be a complete sentence, or it might just be part of a sentence. This will make a little bit more sense with some examples. A supplemental nutrient solution was added daily to maintain proper plant nutrition. If we just said a supplemental nutrient solution was added, that's a complete sentence. Right? It has the subject, it has the predicate, including the verb, and then the rest of the sentence is additional information. It's telling when the solution was added and why it was added. That's additional information, but it's not necessary to have a complete thought. I mean, the sentence is better with that information, but it's complete without the information. So the independent clause is highlighted in blue there. A supplemental nutrient solution was added. The second example, soybean is an agronomically important crop. That's the independent clause, and it's the entire sentence. So there's no additional information in this sentence, which is fine. It's not a problem. A third example, we searched the literature for distribution checklists and used personal contacts to collect data sets of Lepidoptera on true islands. So there's actually two independent clauses in this sentence. The first one is we searched the literature. That could be a complete sentence, but there's more information in the sentence. There's also a second independent clause there, and is sharing the subject with the first independent clause, we used personal contacts. That could be a complete sentence also. But you see that there are some phrases that add information to those independent clauses. For distribution checklists, then there's a conjunction to connect ideas. We used personal contacts to collect data sets of Lepidoptera on true islands. So 3 phrases of additional information for that second independent clause. All right, so we have talked about an independent clause. You might have guessed that with the term independent clause, there's probably also a term for a dependent clause, and that is true. So what is a dependent clause? It is a clause, so it has a subject and a verb, and it's part of a sentence, but it is not a complete thought on its own. So it cannot be a complete sentence by itself. It's dependent on the independent clause that's in the sentence. So let's look at some examples of dependent clauses. So we have the independent clause marked in blue, the dependent clause marked in red. We designate a state as the system end node of the whole network for the purpose of collecting tokens after the last observation is processed. So the red part is a clause. It has a subject, it has a verb. Secondly, the potential of treatments included in this study is consistent with previously reported potentials where similar designs, size classifications, and study methods were used. Again, the red part has a subject. It's that long phrase there. And were used is the verb, but it's not a complete thought. That clause depends on the first clause, the independent clause, to make a complete thought. So therefore, it's a part of a sentence, but it's not able to stand on its own. This third example has the dependent clause coming first, before the independent clause. You'll see that sometimes. To assess the proportion of cells in which treatment with Cas9 expressing baculovirus resulted in loss of protein, prometaphase cells were analyzed by immunofluorescence microscopy. And the fourth example is, we must create transition links to all the HMMs that immediately follow the first HMM after the model internal transition links are created. Now we can put together independent clauses and dependent clauses in ways that make different types of sentences. So let's look at 4 different types of sentences. There is a simple sentence where there is one independent clause, and then when you have 2 or more independent clauses, you have a compound sentence. And these are typically joined by a conjunction like and or but. So compound has 2 or more independent clauses, whereas a complex sentence has 1 independent clause and 1 or more dependent clauses. So that last slide we just looked at had 4 examples of complex sentences. Then you can also have a compound complex sentence where you have 2 or more independent clauses. That's what makes it compound. And you have 1 or more dependent clauses. That's what makes it complex. Now, I would advise you against writing compound complex sentences in your scientific writing. It's just too hard for the readers to follow that and parse all of the different elements. I would suggest that you mostly write simple sentences and then occasionally throw in a compound sentence or a complex sentence. It's okay to have those. If you have entirely simple sentences, it's going to get a little bit boring for the readers. If you have entirely compound and complex sentences, it's going to make your readers tired because it's a lot more work for them. So use a mixture of different sentence types of these first 3 types, mostly simple, some compound, some complex. Okay, we have now talked about the 8 parts of speech and we've talked about sentence structure. This next part of this lesson will talk about tenses, articles, and plurals. I mentioned earlier in this lesson that verbs are really the key to English sentences. And verbs are going to have different tenses in English. We have the present tense, that's what's happening now. And we have the past tense, that's what happened before now. And we have the future tense. That's what's going to happen after now. It's going to happen in the future. Most of the verbs are going to have tenses. Now, it gets a little bit more complicated because each of these 3 tenses has 4 different subcategories. We have the simple, the progressive, the perfect, and the perfect progressive subcategories of tenses. So I'm going to show you a chart now, and this chart is going to have all 12 categories based on the verb write. The simple present tense is write. The simple past tense is wrote. And the simple future tense is will write. Now if we look at the other categories, I'm not going to read this whole chart to you, but I would say stop the video, spend 3 or 4 or 5 minutes looking at this chart. And then when we come back, I'm going to tell you a short story using all of these tenses and subcategories of tenses. Okay, so here's the story. I write manuscripts as part of my job. I am writing a manuscript now. I have written half of it. I have been writing it for 2 weeks now. So those are the 4 subcategories of the present tense. Now let's look at 4 subcategories of the past tense. I wrote a manuscript before this one. I was writing it for a few hours every day. I had written the introduction and materials and methods after 2 weeks. When it was finished, I had been writing it for 10 weeks. Okay, now for future. I will write this manuscript and then show it to my co-authors. I will be writing again tomorrow. By the time I stop for the day, I will have written another 2 pages. When it is done, I will have been writing every day for 10 weeks. All right, so that wasn't too hard, right? We have all 12 categories of tenses in that short story. 12 sentences, 12 tenses. Let's now talk about articles. So articles are a tricky part of English for a lot of people that grew up speaking a different language. But they're a really important part of English in terms of coherence in your sentences. So it's important to understand how to use articles, when to use them, and which one to use. Now, what are articles? Articles are a special category of adjectives, and they are used with certain nouns. There are only three articles, and they are a, an, and the, or the. You can pronounce it either way. A and an are indefinite articles. That means that they do not refer to a specific noun. You use them with a certain noun, but that noun is not referring to a specific organism or a specific technique or a specific car or whatever the case might be. So how do you know when to use a and when to use an? You'll use a before consonant sounds, and you'll use an before vowel sounds. The is a definite article in contrast with a and an. And so what that means is it refers to a specific noun that is known to the reader. So how is it known to the reader? Either it has been specified in a previous sentence or a previous part of the sentence, or it's obvious based on the context. Let's look at some examples. I wrote part of a new manuscript, then I went for a walk. I'm going to do an experiment for the paper I am writing. It will be the last experiment of my PhD program. Doing the PhD program has been an awesome learning experience. These four sentences, they go together to tell a short story, and they illustrate the basic rules of using articles. So the first one is a. Why is it a instead of an? Because the following word is new, and that's a consonant sound. So it's a new manuscript. So we're using a instead of the because we haven't specified what manuscript it is yet. So now I've just told you it's a new manuscript. So when I go to the next sentence, I refer to the paper I am writing. So paper and manuscript are interchangeable terms, and I use the because I've told you that I'm writing a new manuscript in the first sentence. So now the paper is known to you. It's a specific noun. But in that sentence, experiment is new. Okay, we haven't specified an experiment yet. So it's an indefinite article. And it's an instead of a because it's a vowel sound. So as we go to the third sentence, I'm talking about experiment again. But since I have told you in the previous sentence that the experiment is specific to the paper I'm writing, now I'll switch to the definite article, the. Will be the last experiment of my PhD. So notice that PhD program, that noun doesn't have an article. Okay, why not? Because it has my instead of an article. It has my PhD program. So it doesn't need an article because it has that my modifier. And then in the fourth sentence, I use the definite article the because in the third sentence, I've told you that I'm talking about my PhD program. So now it's a definite noun. Doing the PhD program has been an awesome learning experience. So I hope that illustrates how to use articles. There are a lot more rules to using articles. So if you need to dig deeper, if you're coming from a language that doesn't use articles, and this is a hard concept for you, you can look to some outside sources if you need to dig deeper. What I want to emphasize in this lesson is that articles are extremely important for English language writing. Now we talked about verbs being past, present, or future. Verbs can also be plural, and nouns can also be plural. So if it's a singular noun, it's talking about that there's one item that noun is referring to, the quantity of one. And if the quantity is more than one, you need to use a plural noun. And if you use a plural noun, you also need to use a plural verb. So the noun and the verb have to match, singular with singular, plural with plural. This is very important. Going back to articles, the article a and an are by definition singular. So if you see something referred to as a, like a pipetter, we're talking about one single pipetter. If you say pipetters, plural, you don't use an article. Okay, so a and an are not used before plural nouns. but the can be. Articles are a little bit complicated, but the point here is that we need to make sure that the nouns and the verbs match each other in terms of singular or plural. Let's look at some examples here. So I'll have two sentences and I'll show you the correct way they should be, and then I'll show you the way that they should not be written that I see commonly in scientific writing. All right, so first we have the correct version. The most differentially expressed genes between uninfected and infected bees were classified into three groups. What is the subject in this sentence? It is the most differentially expressed genes. So the verb of the sentence needs to go with the word genes. Plural genes, and we have a plural verb, were. So that is correct. That's how it should be. Now if we look at that first sentence in the wrong category, what it says now is the most differentially expressed genes between uninfected and infected bees was classified into three groups. So there's two plural mistakes in this sentence. The first one is that we have a plural noun, genes, and then we have the singular verb, was. So you wouldn't say the most differentially expressed genes was. You have to say genes were. So that's the first mistake. And then the second mistake is classified into three groups. So if you have three of something, then it should be groups. It should be plural. Now let's look at the second example. It is likely that there are subtle molecular changes present in those patients that suffer early relapse. Now this one's a little bit more complicated because the sentence starts with a pronoun. It is likely is the subject. And so we have to go farther into the sentence to see what it is referring to. So it is referring to molecular changes. So changes is plural, so we need to use the plural verb of the to be verb, which is are. So the singular would be is, and that would be incorrect. Let's look at a few more examples of subject-verb agreement or lack of agreement. So we'll look at two correct sentences and two incorrect sentences. Okay, first, correct is a basic challenge of using droplets for transcriptomics is to retain a molecular memory of the identity of the cell from which each mRNA transcript was isolated. So our main noun there is challenge. That's singular. And the clue for that is a. It says a basic challenge. So a indicates that a challenge is singular. And so we have the singular is. Now, the second example, HeLa cells were incubated in the absence or presence of PLK1 kinase inhibitor. So cells is plural, were is plural, they agree. This is correct. Let's look at some wrong examples where they don't have agreement between subject and verb plurality. The potential of treatments included in this study are consistent with previously reported potentials, where similar designs, size classifications, and study methods were used. All right, now this one is a little bit tricky. I mean, I can see why people would write it this way, because it says the potential of treatments. So treatments is plural. It's a plural noun. And so you might think, well, I need to use the plural verb, are. But treatments is not the key subject in this sentence. Potential is the key sentence. Of treatments is a modifying potential. So we're talking about the potential is, it should be the potential is consistent with previously reported potential, right? Not the potential are consistent. Okay, so it's a little bit tricky. I hope that makes sense to you. So what you need to do is look for the noun that goes with that verb. It's not necessarily how it first appears. A second example, anthropogenic interference in freshwater river systems have increased rapidly since urbanization has reached all corners of the globe. So again, have is following systems. And so systems is plural. You might think I should use the plural verb, but the verb is referring to interference, which is singular. It's a singular concept. So it should be has, not have. Anthropogenic interference has increased. All right, now that we have covered tenses, articles, and plurals, it's time to move into the last part of this lesson, and we'll talk about active voice, passive voice, and we'll talk about first person, second person, and third person. All right, so what is active voice and what is passive voice? What does that mean? So active voice or passive voice is determined by the verbs that are used. Active voice emphasizes who is doing the action. That's what we call the agent. Whereas passive voice emphasizes the receiver, or the what or who the action is being done to. So we're either going to emphasize the agent or the receiver. So here are some examples. I wrote a manuscript for publication. So wrote is an active verb and it's emphasizing I. I wrote. So I did this. I am the agent and the action I took was I wrote. Now, if I wanted to change that sentence to the passive voice, I would say a manuscript was written for publication. Who wrote the manuscript? It doesn't say. If we just read that sentence by itself, you could assume it was written by the author, or you could assume that the author is referring to someone else who wrote the publication. But the point is, the agent is minimized, right? The agent is subordinated. We don't really know anything about the agent. What we know about is the manuscript. Now let's look at some scientific writing sentence examples. A draft of A. mellifera genome sequence was published in 2004. That's the passive way to write that sentence. So we see the receiver, that's the draft genome sequence. The action was somebody published it. So someone did something to that genome sequence, which was published. Now the active way to write this is we published a draft of A. mellifera genome sequence in 2004. Or it could name a person. Group X published a draft of A. mellifera genome sequence in 2004. That's active. So now that you know what passive voice and active voice are, when you want to emphasize the agent, use the active voice, and when you want to emphasize the thing that's being done to, then use the passive voice. So for example, when you're writing materials and methods, you want to emphasize the materials, you want to emphasize the methods, not the person doing experiments. So you write in the passive voice. So maybe in the introduction, when you're giving the background information, you might want to emphasize that you were the group that discovered this background information, and so you would use the active voice. And in later lessons, we'll talk in more detail about situations where the passive voice is preferred or the active voice is preferred. Now let's talk about grammatical person and point of view. So this is first person, second person, third person. What do those terms mean? First person is when the writer is speaking about the writer's own actions. And so they'll use words like I, me, mine, we, or our. Second person is when the writer is speaking directly to the reader. And they'll use words like you, your, or yours. So they're giving you instructions. Third person is when the writer is speaking to the reader about a person or thing that is not involved in the conversation. And so they'll use things like he, she, they, them, it, or maybe no pronoun at all. So what do you think most scientific writing is going to use? First person, second person, or third person? Are some of these rarely used, or some of them frequently used? All right, here are some examples. In the study, we used RNA-seq to investigate gene expression, splice variants, TSSs, and differential promoter usage in honeybees. So this is a first person. And second person, the same sentence would say, you can use RNA-seq to investigate gene expression, splice variants, TSSs, and different promoter usage in honeybees. So if the authors wanted to refer to themselves in the third person, they could do that in this way. In this study, the authors used RNA-seq to investigate gene expression, splice variants, TSSs, and differential promoter usage in honeybees. That's pretty unusual and it's awkward. Usually you would write in a third person point of view without referring to the agent at all. So, for example, in this study, RNA-seq was used to investigate gene expression, splice variances, TSSs, and differential promoter usage in honeybees. So, 4 different ways we could use grammatical person and point of view. Which ones are the most common in scientific writing? So if you said the first and the last, I agree with you. So I would recommend against using second person, third person referring to the agent. And I would also recommend against referring to yourself in the third person. So most of the time you're going to use either the structure that's in the first sentence or the fourth sentence. Okay, so as we wrap up this lesson, we've covered a lot of material, but I'd just like to look at the learning outcomes for this lesson. And that's going to give you an idea of how to spend your time practicing putting this information into use. So again, the learning outcomes for this lesson were to list and define the parts of speech, to be able to classify words of a sentence into parts of speech, identify the subject of a sentence, identify the main verb in a sentence, explain when to use past, present, and future tense, be able to use singular and plural nouns and verbs appropriately, be able to define passive voice and active voice and explain when to use them, and be able to define first, second, and third person and know which ones to use. So that concludes this lesson. Go out, put it into practice, work on your worksheets, take the quiz, and when you feel like you have mastered this material, then you're ready to move on to the next lesson. All right, in the meantime, keep writing every day, and as you do, happy writing. Hello, scientific writers. Welcome to the next lesson. This lesson is on technical writing fundamentals. So what we'll talk about today is the overall field of technical writing and the main considerations you need to take into account. Let's start with talking about the learning objectives for this lesson. Is that after this lesson you will be able to describe the settings where technical writing is used. You will be able to list and define the main considerations for technical writing. You'll be able to explain similarities between technical writing and other forms of writing, and explain differences between technical writing and other forms of writing. You will also be able to describe the purpose of your writing task, the scope of your writing task, and the audience for your written document. So by the time you move on to the next lesson, make sure you can do all of these learning objectives. So I'd like to start this lesson with a story that illustrates that sometimes technical writing is a matter of life and death. So let's look at this warning label. Danger. Mild exposure to CO, carbon monoxide, can result in accumulated damage over time. Extreme exposure to carbon monoxide may rapidly be fatal without producing significant warning symptoms. All right, so you read that and it probably doesn't have a big impact on you because it's written in such a way that it's really hard to relate to. What is mild exposure to carbon monoxide? How do you know if you've had mild exposure? And what does it mean by accumulated damage over time? I mean, is this something that is like smoking, for example, where you smoke one cigarette and nothing happens, but if you smoke cigarettes for 20 years, your chances of getting lung cancer are greatly increased? Is it something like that? We don't know from this warning label. It's really not clear. Also, how do you know if you've had extreme exposure to carbon monoxide? How do you know if you're getting exposure at all? This is a warning label that used to be on gas-powered space heaters. And at this time, in the United States, there were several hundred people who died every year from using these gas-powered space heaters because if they had a power outage, they would bring them into the house and turn them on to warm up the house, or they would use it in a garage or some kind of a building, and they would produce carbon monoxide and people would die from carbon monoxide exposure. And so eventually this warning label was rewritten, and it was rewritten to the warning label you see here. It says, danger. Using a generator can kill you in minutes. Generator exhaust contains carbon monoxide. This is a poison you cannot see or smell. Never use inside a home or garage, even if doors and windows are open. Only use outside and far away from windows, doors, and vents. Now, I think this is a much, much better warning label because it's concrete. We know exactly what they're talking about. It can kill you in minutes. You don't have to wonder about what damage over time means or rapidly be fatal. It's very, very easy to understand this label. And it tells you that you cannot see or smell carbon monoxide. So it gives you a better feeling for the level of danger of this substance. And it also tells you exactly what not to do and what to do. So never use it indoors, always use it outdoors. And once this label went on to these space heaters, the death rate went down extremely. And it was no longer a big issue. So your technical writing is probably not on warning labels. If you're taking this course, you're probably writing a thesis or a dissertation or a publication or a grant proposal. But still, I think this really illustrates that the clarity of technical writing is really important for getting the message across. And people may not die if you don't write well. But at the same time, you might save some lives by writing well. Maybe if you're working on something in the medical field or engineering field where people are using something that is a life-saving device, or if they use it incorrectly, it's a life-taking device, then your technical writing might be that important. So where is technical writing used? Let's look at a few examples. Technical writing is used in instruction manual, in user documentation, in technical reports, in business reports, press releases, grant or project proposals, and journal articles. And this course is about scientific writing. And scientific writing is a subset of technical writing. We're focused on the grant or project proposals and journal articles. And a thesis or dissertation is typically written like a journal article, so it falls under that category. Now let's look at what the main considerations for technical writing are. So the three things you need to take into mind are purpose, scope, and audience. And we're going to delve into some greater detail about each of these considerations of technical writing. Let's start with purpose. But before we dig into that, I want you to think about when you are reading scientific writing, what's your purpose? Okay, why are you reading this material? When I have asked this question in face-to-face courses I've taught or in workshops that I've taught, I usually get some answers like this. I'm reading to learn how to do a new method, or I'm reading to verify some facts about the research that I'm doing, some background facts. Or I'm reading to learn about a new topic that I've started researching. Or I'm reading to find references to cite for my grant proposal or to cite for my journal article or my dissertation. What we can see is that there are a lot of purposes for reading. So we can think of passive purposes and we can think of active purposes. In terms of passive purposes, we might be getting notification. We might be getting information that reassures us. For example, like if you feel like you're getting sick and you look up the symptoms of the common cold versus the symptoms of COVID-19, and that helps you decide if you're going to go see a doctor or not. You might read to feel a sense of unity, to be entertained, to get instruction, so to learn how to do something, to learn how to do a new hobby, so to enjoy, to hear advice, to be inspired, to review a topic, to understand some new information, or to learn. More active purposes of reading would be things like examining, quantifying, assessing, making informed decisions, to interpret, to evaluate, to judge, to resist change, to criticize, to ridicule, or to disprove something. Now think about when you are writing, when you're the author, what is your purpose for writing? And what I want you to do when you're thinking about that is think about, is my purpose for writing the same as my purpose for reading? It's probably not exactly the same, but when you think about your purpose for writing and your audience's purpose for reading, that can help you write in such a way to meet the needs of your audience. So some of the purposes that you might have for writing are under these three major headings: to inform, to persuade, or to entertain. Those are the main three purposes for any type of writing. So informative purposes for technical writing might be things like to inform, to describe, to define, review, notify, instruct, advise, announce, explain, demonstrate, or illustrate. Whereas persuasive purposes would be things like to persuade, convince, influence, argue, recommend, to effect change, to advocate, to urge, to defend, to justify, or to support. And then I have entertain column here, and that is empty. Why is it empty? Well, because most technical writing has a purpose of informing. It has an informative purpose. Sometimes your technical writing might have a persuasive purpose. So if you're writing a grant proposal, you might be persuading the reviewers that your project has a high likelihood of success and that they should fund you. If you're writing a journal article, you're probably not trying to persuade people unless you're writing about something that could change policies, but you are writing to inform. Now, the reason I left the purpose of entertaining blank on the previous slide is because the purpose of technical writing is never to entertain, by definition. Now, that does not mean that your writing cannot be entertaining. You should try to write writing that's enjoyable, maybe even entertaining, but the purpose is not to entertain. So let's look at some examples of technical writing where we can think about what was the purpose behind that writing. So here's an article from the Minnesota Department of Health. The title is Protect Yourself and Others, COVID-19. So if we just glance at the content of this short article, it's talking about distancing, and it says stay home as much as possible, stay at least 6 feet apart from other people, telework if you can, avoid close contact with people who are sick. If you're 65 and older and have certain underlying medical conditions, stay at home and avoid situations where you could be exposed. And the article continues with these kinds of tips. So what do you think the purpose of the author of this writing was? To me, this writing looks like it had a persuasive purpose. So it's trying to persuade people to do these things. It's trying to influence them to do these things and recommend and even to urge people to stay at home and stay far away from other people. It's not so much explaining why, it's just telling them what to do. So this is a persuasive piece. Now let's look at this piece. This is an article from a journal called Engineering, and the title of this article is Reuse of N95 Masks. And if we glance through there and we look at, say, the second paragraph, it's saying, how do you kill a virus? It's not very hard as long as the virus is not in a human body. The simplest way is to take a mask and let it sit out for 2 weeks. The virus tends to die after 10 days or so. However, this solution is not always practical. And then we look at the third paragraph. It says, 5 fast ways to kill a virus. And then over on the right, you can see that they have a chart there showing sterilization, charging, and testing of reusing these masks. So what do you think the purpose behind this article was? To me, this is an entirely informative article. It's not trying to persuade anyone to do something or instruct them to do anything. It's just telling you the information about how to kill a virus, and then it's going to go into information about how to sterilize a mask for reusing it. So this one is entirely informative. Let's look at another example. Okay, this is from the Alaska Department of Health and Social Services, and it says, Mask Up Alaska. If more people wore masks, we could slow the spread of COVID-19. Wearing a face mask is especially important because with COVID-19, people can be contagious without having symptoms or knowing they are sick. Masks cover the mouth and nose to prevent the spread of respiratory droplets which could contain the virus that causes COVID-19. Be a hero, wear a mask. So how about this one? What do you think is the purpose or are the purposes of this short article? So if you said both to inform and persuade, then I agree with you. So if we look at some of these options, it's informing about how masks slow the spread, it's instructing on how to use it, it's explaining why they work, and it's also trying to persuade, convince, influence, advocate, and urge. So this one has, I'd say, an equal amount of informing and explaining in it. So now we've talked about the purpose for technical writing or scientific writing. So it's really important when you sit down to write to think about, what is my purpose? Am I looking to inform or to persuade? There are different subcategories of that you could break it down to. Now, for the rest of the lesson, what we'll talk about are the scope and audience together. We're going to talk about these at the same time. So let's say I want to write a technical article. I'm going to write a technical article about fishing. So I need to think about the scope, right? I need to think about the information I should cover. I'm also going to think about the audience at the same time. So what information should I cover? What are the things I need to think about when I'm thinking about the scope? For fishing, I need to think about the genre. Okay, are we talking about fishing in a pond, a lake, a river, in the surf, in the deep sea? Are we talking about fly fishing or lure fishing or bait fishing? Then we also need to think about things like topics. What is the topic I'm going to write about? I could write about new products, new concepts. It could be a buyer's guide. It could be a how-to. It could be a person profile. It could be about a place to go or an event, or it could be a review or a comparison. Then I also should think about different elements of fishing. So there are things like the weather or the tides and how they affect how you would go about fishing. We could talk about techniques, different gear makes and models, components, clothing, accessories, safety, or technology. We also need to think about the audience. Who are we writing for? Are we writing for a beginner, somebody who occasionally fishes, for an enthusiast or an expert or even a professional, somebody that's a gearhead? Is this a local? Is it a tourist? And other things that we need to consider. Is there a word count limit? Can I include figures and tables? What about legal considerations? What are the guidelines for writing this article? When is the deadline for it? What's the budget? How much can I spend when I'm writing this article? And what is the reach? Is it going into a publication that will go out to 100 people? Or is it going on the internet where anyone can see it? Or is it going in a publication with a circulation of 100,000 people? So there are a lot of different things to think about as you're determining the scope and the audience. Now let's look at one more example of one of these online articles about COVID-19. Now let's talk about the similarities between technical writing and other types of writing. One thing that's similar is the process. So there is still the same process of pre-writing, drafting, revising, and editing. So if you were going to write a poem or a novel or a short story, you would still follow these same steps. You would need to sit down and think about what you're going to write, do some pre-writing. You would write a draft, and then you would revise it, and you would edit that draft. So these are all very similar. Also, it's similar in that it takes time and effort. You don't just sit down and write a grant proposal or a journal article in a day. It takes a long time and it's a lot of work. Just like other types of writing, it requires strong language skills. And it requires research. So you need to research your audience, your topic, and your purpose. And it also has rules, conventions, and style. How is technical writing different from other types of writing? So one of the differences is the audience. So if you're writing an a novel or a short story, you're going to have a different audience than if you're writing a scientific journal article. So the technical writing audience is usually highly specific and technologically savvy in that field. Another difference between technical writing and other forms of writing is that in technical writing, the organization is simple and it strives for clarity and readability. Another difference is that figures, tables, and illustrations are commonplace. They really help the reader understand the technical writing, so it's good to use figures and tables and such. Another difference is that the author of technical writing is a technical expert. Even if you don't feel like you're an expert, you are the technical expert because you are writing this technical article. Another difference is that even when the purpose is to persuade, the information needs to be objective, factual, accurate, unambiguous, and free from emotion or opinion. Now, we're talking about personal opinion here, not professional opinion. Another difference is that it uses highly specialized language and technical terms. And we're going to talk in later lessons about why it's important to limit your use of jargon, but even limiting technical terms to when it's absolutely necessary is something that's important for good technical writing. And the final difference between technical writing and, let's say, creative writing is that the tone is formal, specific, precise, direct, and clear. The last thing I have for you in this lesson, a checklist for technical writing. So we've already mentioned a lot of the items that I have on this checklist, but I've come up with 8 C's for technical writing that you want to make sure that you are accomplishing. The first one is that it's correct. So if your writing is not correct, if it has errors, you're going to lose all credibility with your audience. They expect everything in a technical article to be 100% correct. You also want to make sure that it's complete, that you haven't left anything out. And it's surprisingly easy to leave something out when you're an expert because everything seems obvious to you. So you really have to think back to your audience and make sure that you're not leaving something out that the audience doesn't know, that to you feels like everyone should know that. Also make sure that it's clear and concise. So when I say it's clear, what I mean is that you don't confuse the readers by saying something that can be interpreted in different ways, and it's easy to understand. By concise, what I mean is it's as short as it can possibly be while not losing any information. It doesn't necessarily mean that it's short. It just means that it's as short as it can be. Another C is cohesive. So cohesive means that the entire piece of writing is organized in a way that all of the parts fit together. You don't feel like there's something that's there that shouldn't be there, or that it's not organized well. It should also be consistent. So consistent means that there are no inconsistencies in the writing, and it means things like using key terms the same way every time, and you're not giving different information in different parts of the article. It should also be considerate, and by that I mean that you need to take your readers into account and don't make extra work for them. So write it in such a way that they don't have to go to outside sources to look up terms or to look up additional information to understand your article. And it needs to be convincing. So when they read it, you want them to agree with what you're saying. You don't want them to walk away thinking, oh, I'm not so sure about what that author said. I don't really believe what they're saying. All right, so we have arrived at the end of this lesson. I'd like to quickly go over one more time the learning outcomes. So again, they are to describe settings where technical writing is used, list and define the main considerations for technical writing, explain similarities between technical writing and other forms of writing and also the differences, and describe the purpose, scope, and audience for your written document. So go ahead and work on the worksheet for this lesson and also take the quiz. And as you do, happy writing. Hello, scientific writers. Welcome to the next lesson. This lesson is on readability and how to achieve it. So what we'll talk about in this lesson is the definition of readability, how readability is calculated and how it's viewed by readers, and I'll give you a lot of tips on how to make your writing the most readable that it can be. And so if your writing is more readable, your readers are more likely to understand what you're talking about without a lot of effort. The more likely they are to enjoy reading it. And if they enjoy reading it, they're going to finish reading it. And that means that your acceptance rates are going to improve, your rejection rates are going to go down, and probably you'll get more citations too. So let's get started. First, let's talk about the learning outcomes for this lesson. So after you complete this lesson, you will be able to define the term readability. You will be able to explain the components of text readability. You'll be able to identify grammar and style choices that reduce readability. You'll be able to edit your sentences to increase readability. And lastly, you'll be able to describe strategies to increase visual readability. So what does readability mean anyway? Well, let's look at a dictionary definition of readability. This is from oxforddictionaries.com. The main definition is the quality of being legible or decipherable. And then this sub-definition 1.1 is the quality of being easy or enjoyable to read. And so that's the definition we are going to focus on. We're going to talk about ways to make your writing easy and enjoyable to read. Now, how do you evaluate readability, or how do you measure readability? Well, there are some actual formulas that can be used to measure readability. These include the Flesch reading ease, the Flesch-Kincaid grade level, the Gunning-Fogg index, and the SMOG grade, which stands for Simple Measure of Gobbledygook. And each of them takes into account features such as the number of words per sentence, in other words, sentence length, and features like the percentage of polysyllable words. And it factors these features to give a readability score. So what you can do is go online and search for readability test tool or readability calculator or something like that, and you'll find some websites where you can paste in your text and it will give you a readability score. Now let's look at a graphic on how readability scores factor into real-world readability. And so these indexes have been tested over and over again. They were tested as they were developed in the 1940s, and they've been tested many times since then. And so this is what the researchers found out. Let's look at this graphic. And what this is comparing is the sentence length, the left-hand y-axis, to the Flesch reading ease score on the x-axis. And so what you can see is that as the sentence length increases, the Flesch reading score decreases. The lower the score, the lower the readability. And that can be seen in the blue bars. So for example, with the Flesch reading score of 90 to 100, we're looking at a sentence length of about 8 words per sentence. So when we see reading scores in the category of 0 to 30, we're looking at sentence lengths of about 29 words per sentence. These are average sentence lengths. So some will be longer, some will be shorter. On average, they're about 29 words per sentence. Imposed onto this graph, we see this green line. And this represents the percentage of adults in the United States who can understand this writing. So with Flesch reading ease score of 90 to 100, 90 to 100% of adults can understand that writing. And as you go to scores of 80 to 90, it drops off a little bit. Scores of 70 to 80 drops off a little bit more. Now when you have Flesch reading ease scores of 60 to 70, now it's fewer than 90% of adults can understand this writing. And from there, it takes a precipitous drop. And when you get to scores of 30 and less, now we're looking at less than 5% of adults that can understand that writing. When you've eliminated 95% or more of the entire population from your audience, what does that do to the reach of your work? It makes it much smaller than it would be otherwise. If we have scores of 30 to 50, now we're looking at about 30 to 35% of adults that can understand reading scores of 30 to 50. So that still cuts out a major percentage of the audience, but you should be able to capture the entire audience of scientists in that 30 to 50 category. But if your reading scores are below 30, you're eliminating even other scientists from being able to understand what you're writing. Now let's look at some research. I'm going to show you a few different research articles where the authors have studied the readability of scientific writing over time or at specific points in time. So we'll start with this study from 1983. And what they did was they looked at the readability of scientific papers from a handful of journals here, starting in about 1800 and going until 1980 or so. And what we can see is that the early publications around 1850, they had a Flesch readability ease score of about 70. And then as we go to 1875, the scores are similar, but they might be trending downward. As we go to 1900, they're definitely trending downward. We're looking at scores of around 50 at that time. 1925, now we're getting into scores that are well below 50. They're probably averaging a little bit over 30. 1950, we're down to 30. And in 1980s, we're down below 30. Now, these authors stated that they felt like the readability scores had leveled off in the 1980s, and they were going to be consistent from that time onwards. They were still saying that it's not a good thing that the scores had dropped so much, making scientific writing much less readable than it was in previous decades. Now here's another study. This one is from 2002, published in the British Medical Journal. And in this study, they studied the mean Flesch reading ease scores for two different journals, the British Medical Journal and the Journal of the American Medical Association. They also showed the FOG score here. With the FOG score, a higher number is less readable. So it's the opposite direction of the Flesch reading ease score. But let's just focus on the Flesch reading ease score so we can compare across studies. So in 2002, the Flesch reading ease scores for the British Medical Journal was around 32 if you averaged it by journal. If you averaged it by author, it's a very similar number. In the Journal of the American Medical Association, the score was more like 27. So the American Journal was not as readable as the British Journal, but both of them are hovering around that 30 score, which, remember, 30 or less, it's going to exclude at least 95% of the adult population. Let's look at another study from 2006. And they looked at three medical journals, the Archives of Surgery, British Journal of Surgery, and the ANZ Journal of Surgery. And what they found were, again, low readability scores. Now they're even lower at this point. This is just a few years later. You can see all of the raw data here. And if I average this with my eye, we're looking at Flesch readability ease scores for the Archives of Surgery around 15. And it looks like between 15 and 20 for the British Journal of Surgery and around 20 for the ANZ Journal of Surgery. So again, they're going to exclude about 98% of the population from being able to read these articles with these low readability scores. Now let's look at the most recent article from 2017. And in this article, they took a very large corpus of scientific writing going back to 1880 up until around 2015. And you can see by looking at this trend that by the 1920s, we were below Flesch reading ease scores of 30, and it was just a steady decline. Now, there was kind of a plateau during the 1980s, just like that other article we looked at said, but the plateau didn't last very long, and by the 1990s it started dropping again, and then at 2000 the reading ease score started dropping very quickly. And you see now that it's hovering at around 10. Now that is very unreadable. That makes very difficult reading. And so you're not doing your readers any favor if you're producing work that has that low of a readability score, because it makes their job really hard. It makes it really hard for them to understand what you're writing about. That not only hurts your readers, but it hurts you as an author as well, because your work will have less of an impact. So as a reminder, when we have flash reading ease scores of less than 30, very few people can read that work. And we've got scores way below 30, and they've been below 30 for 100 years. As your instructor, what I recommend to you as an author is to try to get your flash reading ease scores into the 30 to 50 category. Now you can do that most of the time by implementing the tips that you will learn in this lesson. Now I'd like to tell you that the flash reading ease score works. As I mentioned, it's been tested time and time again, and it works. It has a high degree of correlation with comprehension by readers. And because the formulas use sentence length and percentage of polysyllable words in calculating the flash reading ease score, your first steps in improving your readability score should be to reduce sentence length and reduce the percentage of words that have more than 2 syllables. And that might sound like something that is really hard to do, but it's not. And I'll show you how to do it. So we're going to go through a step-by-step process. Step 1 is to run your text through a readability software and note the score and then the score driving elements, which are going to be primarily sentence length and percentage of complex words. You're going to tackle them both, but it's good to know which one is driving the score. Step 2 is to break up long sentences. So find those compound, complex, and compound complex sentences and make them into simple sentences. You might take one sentence and make it into 2 sentences or even 3 sentences sometimes. So that's a step number 2. Step number 3 is to replace complex words with simple words when possible. So some examples are changing utilize to use, change investigation to study, and so on and so forth. And I have a downloadable table that has some examples of complex words that are common in scientific writing that you can substitute simple words. Download that and take a look at it as you're working through this lesson and revising your work. Now, along with sentence length and number of polysyllable words, word choice, style, and organization of your writing also have an effect on readability. Now, these things have an effect on readability, but they may not directly show up in the flash reading ease scores. But they will indirectly show up, because as you make these stylistic and word choice changes, it's going to affect sentence length, sentence structure, and it will bring down your reading scores indirectly. Not directly, but indirectly. So we're going to start off by tackling abstract nouns. We want to change abstract nouns to concrete nouns whenever possible. So stringently evaluate your nouns and see if they're abstract or if they're concrete. So what do I mean by that? What is an abstract noun? An abstract noun is a noun that refers to ideas, concepts, qualities, or states. Refers to things that are abstract in nature. They are often formed from verbs or from adjectives. And we'll see some examples in the next slide so you'll know what I'm talking about. Those are abstract nouns. What are concrete nouns? Concrete nouns refer to things you can see, hear, touch, taste, smell, or feel. Those are concrete nouns. Abstract nouns are harder to understand. because what you have in your mind as a concept might be different than what I have in my mind as a concept. And to make sure that we have the same idea for this concept, it takes a lot of explaining, and it's very hard to do that. If you can use concrete nouns, that's much easier to understand. So using too many abstract nouns is going to decrease readability greatly. All right, so we're going to look for excessive abstraction. And when we find excessive abstraction, we're going to eliminate that, and we're going to change it to concrete terms. Let's look at an example of changing abstract nouns to concrete nouns and the side effects of doing that. So here's a sentence that I pulled from the literature. It says, adaptation to fluctuations in available nitrate involves multifaceted responses in distinct developmental programs. Highlighted in blue are the abstract nouns. Those include adaptation, fluctuations, responses, and programs. None of these are things that you can see, hear, touch, taste, or feel. The underlined word involves, that's the verb in this sentence. So the subject in this sentence is adaptation to fluctuations in available nitrate, and the verb is involves. Now, involves is not a very active verb. It's not a very strong verb in my opinion. It's kind of wishy-washy. And the subject of this sentence, it doesn't tell us who the agent is. We don't know who is doing the action here, who or what. We just know something is going through adaptations to fluctuations. So let's think about how to take this sentence that's very abstract and has kind of a weak verb and make it into something that's more concrete and more active. So this is what I did with this sentence. And this sentence is about plants. Plants adapt to fluctuating available nitrate using multifaceted responses that affect development. So let's walk through what I have done here. First, I gave the sentence an agent, plants, and that is now the subject. So the subject before was adaptation to fluctuations in available nitrate. Now the subject is plants. And the verb has changed from involves to adapt. We know what the plants are doing. They're adapting. And what are they adapting to? To fluctuating available nitrate. So now I have the word fluctuating as an adjective for nitrate, fluctuating nitrate. Before, it was used as a noun, fluctuations in available nitrate. And so I've changed it from this abstract noun to an adjective. And how do plants adapt to fluctuating available nitrate? Using multifaceted responses. And so that phrase is similar to what the original phrase was. It said involves multifaceted responses, but now I'm using that phrase, using multifaceted responses as a modifier to explain how the plants adapt. And then for the last abstract noun, I thought about, well, what do developmental programs do? What does that even mean? What are developmental programs? So the outcome of developmental programs would be that development is changed in some way. And so I took out the word program and I changed it to development. So these multifaceted responses affect development. I left responses there because it's okay to have a few abstract nouns. You just want to remove as many of them as possible. And I think the sentence kind of needed the responses here, and I don't think that's really that hard to understand. So I feel like it's an okay way to go. So I feel like the sentence is a lot more concrete than it was previously, but it still has all of the same information. It's now more readable without losing any content. And you'll notice that it's also shorter. It's a little bit shorter, and it's a little bit more punchy. So these are the kinds of edits that I'm going to teach you how to do during this lesson. So let's look at another example. And I've highlighted the abstract nouns in red. Environmental stress elicits rapid and profound responses in plants designed for protection, avoidance, or progeny survival through changes in conditions. Many of the pathways that participate in these adaptive responses are influenced or controlled by epigenetic variations in the cell. Reprogramming of the methylome can produce changes that are transmitted through the gamete, perhaps a key capacity to predispose the next generation for enhanced stress response. So in my mind, that's a pretty abstract passage. It takes a lot of thinking to really understand what's going on in that passage. And it's because of all these abstract nouns that are being used. So how would I rework this? For each sentence, what I did was I looked first for the main verb, and then I looked for the subject that went with that main verb. So in the first sentence, the main verb is elicits, and the subject was environmental stress. So there's no agent there. We don't know who or what is being elicited by environmental stress. And elicit is kind of an abstract kind of verb, and it's eliciting responses. What are these responses? So I changed the beginning of the sentence to plants as the subject and respond as the verb. So plants respond to environmental stress in rapid and profound ways. So that's more concrete, right? We know what is responding, what they're responding to, and how they're responding. Now, what about the second part of the first sentence? So I've ended this sentence much sooner than the original, and I made the second part into its own sentence. So it says, as conditions change, plants protect themselves, avoid stress, or ensure that their progeny survive. So I've taken this word protection, which is an abstract noun, and I've changed it to an active verb, which is protect. Similarly, I've taken the abstract noun avoidance and changed it to the verb avoid. And I changed survival to survive. So protection, avoidance, and survival are nouns that are formed from these root verbs. So we change them back to the verbs. And we're going to, again, introduce an agent into this sentence. So I'll read it a second time. As conditions change, plants protect themselves, avoid stress, or ensure that their progeny survive. So I've taken the first sentence, made it into two sentences. Now let's look at the original second sentence. The verb there is are, and the subject is many of the pathways that participate in these adaptive responses. So we have two abstract nouns in the subject of the sentence. So what I'm going to do to modify this sentence is look for a more active verb and look for a more concrete subject. So I'm going to change it to plants adapt to stress using pathways that are influenced or controlled by methylation of DNA. I took this kind of vague epigenetic variations in the cell and I changed it to something more specific, which is methylation of DNA. So that's really what the author is referring to. When he or she says epigenetic variations, they're referring to something that's not being stated. And that something that's not being stated is methylation of DNA. The third sentence of the original says, reprogramming of the methylome can produce changes that are transmitted through the gamete, perhaps a key capacity to predispose the next generation for enhanced stress response. So, excellent information there, but let's figure out a way to make it more concrete. The abstract nouns are reprogramming, methylome, changes, capacity, and response. The verb is can produce. I'm going to think about what this sentence is about. It's about the methylome and the methylome changing. And then something that is changed is being passed on to the next generation. So I need to think about what is it that's actually changing that's being passed on. And by reading further into this paper, what I found is that it is this methylated DNA. So let's take it and make that the concrete noun and the subject. I've cut out some of this text that really doesn't seem to be necessary once we understand the concrete nature of what's being transmitted. Methylated DNA can be transmitted through the gamete, perhaps a key capacity to predispose the next generation to respond more robustly to stress. The edits that I made took the abstract nouns and changed them into concrete nouns, and in doing so, I changed the sentence structure around a bit. A lot of times what will have to happen is that the verb changes and the subject changes as you're replacing these abstract nouns with concrete nouns. And that makes the sentences usually shorter and definitely much more direct and more readable. I didn't remove all of the abstract nouns. Some of them are still in place, and I've left those highlighted in red. The goal is not to get rid of every single abstract noun. It's just to get rid of excessive abstraction. Let's look at another example. This one says, burial resulted in consistent measures of diversity with increases in richness and decreases in evenness compared to surface systems during decay. All right, so whenever you see something like increases in X or decreases in Y, you can always change that around to X increased, Y decreased. So you're doing two things there. You're getting one fewer word, and you're putting an agent with an active verb. Increases is an abstract noun. Why not change that to an active verb? And so that's the approach I took in this sentence. Here's my suggested revision for this sentence. Burial resulted in consistent diversity with increased richness and decreased evenness compared to vertebrates decaying on the surface. So in addition to that increases in and decreases in being changed, I also just took out the word measures of because it's not necessary. The scientists did measure diversity, but the result is not the measurement of diversity. The result is the diversity itself. So we'll just take out the measures of entirely. So burial resulted in consistent diversity. And then the last part of the sentence where it says compared to surface systems during decay, we have two abstract nouns there. So systems and decay. So we can take decay and make that into a verb, decaying. Vertebrates were decaying. And we don't need to talk about surface systems. Again, that's the authors thinking about their process. And what they were actually talking about is when animals are decaying on the surface of the ground or when they're buried. And so we're going to talk about it in those concrete terms. So again, burial resulted in consistent diversity with increased richness and decreased evenness compared to vertebrates decaying on the surface. Now, I mentioned before that as a side effect of replacing these abstract nouns, you're probably going to change other parts of the sentences as well. And what you're going to find is that as you convert these abstract nouns to concrete nouns, you're usually going to replace the passive verbs with the active verbs. Using passive verbs can make sentences read in the passive voice. And the passive voice is not as readable as the active voice, and it's usually longer. So we want to change these passive verbs. What are the passive verbs? They usually take a state of being verb and combine it with another verb form. Some examples are was conducted, were calculated, is measured, are being collected. Now, keep in mind that scientific writing is going to have a lot of passive verbs, and it's not going to be practical or possible to get rid of all of the passive verbs. And I'm not suggesting that you do that, but I'm saying look at them carefully and think about it. Can I make this passive verb into an active verb? When you can do it, do it. That's a good thing. It's going to make the writing better. Now, the exception is in the materials and methods section. The passive voice is preferred in that section by almost all authors, and so I'm not suggesting that you do this kind of editing in that section. Let's look at an example of getting rid of a passive verb. The sentence says, the subsequent discovery that baculovirus is capable of infecting mammalian cells has resulted in numerous novel applications ranging from basic cell biology tools to potential gene therapy vectors. Now, the passive verb is capable of infecting. So what can we do with that to make the sentence more active? We can just simply change it to can infect. So instead of saying is capable of infecting, baculovirus can infect mammalian cells. And I couldn't help myself. I changed numerous novel applications to many applications and saved one word and got rid of a polysyllable word. Let's look at two more examples. Here are two original sentences on this slide. In bacteria, various formaldehyde detoxification pathways exist. So exist is a state of being verb. The second example, this axis was explained mainly by variables related to flower size and pollinator attraction and pollinator efficiency. So do you have some ideas for how to edit these sentences? Here are my suggestions. Let's give the first sentence an agent and get rid of exist. Bacteria detoxify formaldehyde using various pathways. It has the same information, but this is a much more active construction. So for the second sentence, if you wanted to make it more active, what you could do is just flip the order of the sentence. So instead of having the subject, verb, object as this axis was explained by variables, you could say variables explained this axis. So you make the variables into the agent of the sentence. Now, you might not necessarily want to make that change. It depends on the flow of the paragraph and what you want to emphasize. But if you did want to make it more active, that's a way it could be done. Here's another example of making active verbs instead of passive verbs. The original sentence says, whether transduction of U2OS cells with CRISPR-Cas9 baculoviruses resulted in the disruption of the A, B, and C loci was tested. So that's a really long subject and then a passive verb, was tested. So the first thing I would do is make the verb active and give the sentence an agent. We tested whether transduction of U2OS cells, etc. When I do that, I notice that there's a couple of abstract nouns in this sentence, transduction and disruption. And so I convert these abstract nouns to concrete nouns. And it says, now, we tested whether U2OS cells transduced with CRISPR-Cas9 baculoviruses disrupted the ABC loci. So I've taken these abstract nouns and made them into other parts of speech. So transduction becomes transduced, which is part of a modifying phrase describing the cells, and disruption becomes disrupted. And we also went from 22 words down to 17 words. So that's going to improve our readability scores also. All right, so now we've got a couple more steps in this process. So we already looked at steps 1, 2, and 3. Step 4 is to replace abstract nouns with concrete nouns. And step 5 is to replace passive verbs with active verbs. Once you've done these 5 steps, your readability scores will be quite a bit better. So run your writing through the software again and see how it looks. But let's keep going. All right, here's an example, and I'm not going to read this whole thing to you and explain it because it would just make this video too long and complicated. But I have a paragraph that started off with the flesh reading ease of 8.8, and I applied these techniques that I've just described and got the reading score up to 29.5. So that's almost 30. And we cut it down to 112 words. So why don't you pause the video and read these two paragraphs and see what I did to get the readability score up. Now, there are a few more tricks to make writing more readable, and one of these is to make the writing more relatable. So how do you do that? Well, even scientists who are a lot of times introverts, even us as introverts, we can relate to other people. So one way to increase the readability is to add people as much as possible when it's appropriate, and not just people, but add agents to your sentences. I talked about that already in the examples that we looked at previously about taking a sentence that has no agent and making an agent in that sentence. It might not be a person. It could be a person. So some tips to do that are do change third person unidentified agents to first person with an identified agent. And first person may not have an actual person there. Some don'ts are, don't just add "we found that" in front of your results. So sometimes I see that, and that's really not a good way to do it. It makes your sentences 3 words longer, and it's just artificially adding an agent. And also, don't do it by using author names as the subjects of sentences. And we'll talk about that in a later lesson. Let's look at an example of changing a third-person unidentified agent sentence into a first-person sentence. So this sentence says, different hypotheses could be initially considered in order to explain the absence of chromosome segregation defects in SAC mutants during the normal growth of S. cerevisiae. So what I did is I just changed it to put a person as an agent. We initially considered. The first version, it just said different hypotheses could be considered. We don't know who is considering these different hypotheses. It just says they could be considered. Could be considered by who? Now, if this is in the context of a paper, it's pretty obvious that it's the authors who are considering these different hypotheses. So why not just say that? We initially considered different hypotheses. And that's how I would suggest changing this sentence. I also took out a couple of words in order to explain. I just changed it to explain. You don't need the in order part of that phrase. Here are 2 more examples. No significant difference in the rate of sulfate consumption was observed between AQDS plus and AQDS minus reactors during this phase. All right, so let's think about that. No significant difference was observed. So who was observing it? We could easily say, we found no significant difference in the rate of sulfate consumption. Now we've acknowledged that it is us. The second example, it was expected that detectable gene diversity would be considerably lower than organismal diversity. It was expected by who? By us, the authors. We expected that detectable gene diversity would be considerably lower. And this one is a simple one. When comparing overall peering rates, there were no differences. Just change that to when comparing overall peering rates, we found no differences. That one's simple. It doesn't change the number of words, but it does make the sentence more relatable and more active. As I mentioned, you don't want to accomplish this by simply adding "we found that" in front of results. For example, we found that tree mortality was present in all of the 10 top performing models, with these 10 models containing tree mortality having a combined model weight of 80%. If you just take out the "we found that," that sentence is the same. So "we found that" is not important in the sentence, and I would advise you not to include it. All right, now we have 2 more steps in the process. So step 6 is add people or agents when possible and appropriate. And now we're going to look at step 7. Make your sentences shorter by using concise wording. Now, because you know how the readability formula works, it's sentence length and polysyllable words, you might be tempted to get rid of polysyllable words by using abbreviations. So using abbreviations will reduce the percentage of complex words in your text. But I suggest that you don't do this as a strategy. Using a few abbreviations, 1 or 2 key abbreviations, that's okay. But when you start using abbreviations for every complex term, it really puts a heavy burden on your reader to understand what's going on, because they have to remember all of these abbreviations, and that's not easy to do. So I have a quote here from Steven Pinker about too many abbreviations. He says, "The writers forget that the few seconds they add to their own lives come at the cost of many minutes stolen from their readers. I stare at a table of numbers whose columns are labeled DA, DN, SA, SN, and have to riffle back and scan for the explanation. Dissimilar affirmative, dissimilar negative, similar affirmative, similar negative. Each abbreviation is surrounded by inches of white space. What possible reason could there have been for the author not to spell them out?" So I'm not going to give you a lot of examples of too many abbreviations because I think it's pretty obvious just from this quote what the problem is. But let me give you one example. And this is an example from one time when I was writing a publication. I found a similar publication in my field, and I thought, wow, this will be great for a compare and contrast to the results that I have found. And so I sat down to read this paper, and I was bombarded with paragraph after paragraph just like this one. Furthermore, 86 QE interactions for alkaline tolerance index were found. 17 for LR, 16 for FWR, 17 for DWR, 18 for LH, and 18 for BS. A total of 77 QE interactions for the original trait indicator were detected. 17 for LR, 14 for FWR, 4 for DWR, 21 for LH, and 21 for BS, as well as 3 epistatic QTL for BS. I'll be honest with you, I wanted to read this paper, but I didn't. I didn't finish reading it because I couldn't. It was just too much work for me. I couldn't read all of those abbreviations. I couldn't remember what they stood for, and they were just presented as list after list like this. And so, to be honest, I gave up on this paper. I didn't finish it, and I didn't cite it. Now, we've talked about a 7-step process for improving your text readability, but you also should think about visual readability. What I mean by visual readability is when you pick up the paper and you look at the page, is it something that your brain can see an organization and it can see spaces between paragraphs? Or is it just a big block of text that makes you think, oh, this is going to be hard to read. I don't really want to read this. Visual readability helps your reader, even though it's not in the words, it helps the reader to organize the material in their mind as they're looking at it and reading the work. So you should consider the visual readability at the paragraph and document level, in addition to focusing on the text content. Okay, this is a screenshot of 2 pages, and it has the exact same text. Don't even try to read these, but just looking at them, you can see that the one on the left looks more inviting to pick up and start reading than the one on the right. The text on the left, you see that there are gaps between paragraphs that helps you visually see the paragraphs. There are also subheadings within this results section that helps you visually organize what's happening. It's fully justified so that the lines are even and you see these nice square blocks of text. Compared to the document on the right, where there are no spaces between paragraphs, there's no subheadings, it's not justified at the right, and so it's kind of messy looking. So this is just an illustration of a few things that you can do. But when you're looking at your visual readability, things you want to think about are using formatting features such as italics, bolding, and underlining, using bullet points. If it's appropriate to use different colors, think about the margins, the spacing, the font size, and the font style. Some fonts are more readable than others. Think about the alignment, using boxes or lines if you have graphics, the placement of the graphics, and having enough white space and how that white space is distributed. Now, I'd just like to wrap up this lesson with a quote. And to set up for this quote, what I would like to make sure that you understand is I'm not telling you to do all of these things during your first draft. All of these tips I'm giving you in this lesson and in the following lessons are things that you do during your editing. So your first draft, you just want to get the words down into your computer and saved on a disk. Right? And then you can start working on it. So don't edit as you write. Write first, edit later. And so here's the quote I'd like to show you. This is from Joseph Garland, and it says, "There is no good writing, only good rewriting." As we wrap up this lesson, let's look back on the learning objectives. And I want you to make sure that you can do all of these learning outcomes before you move on to the next lesson. All right, so the learning outcomes again were to define the term readability, to explain the components of text readability, to identify grammar and style choices that reduce readability, to edit sentences to increase readability, and to describe strategies to increase visual readability. All right, that concludes this lesson, and happy writing. Hello, scientific writers. Welcome to the next lesson. This lesson is called Structure Your Paragraphs and Sentences for Impact. And so what we'll learn in this lesson is how to write a paragraph, and it might sound obvious, but it's not entirely obvious. There are some important considerations to take in mind for writing a paragraph, and there are also important considerations to take in mind for writing the sentences that go into that paragraph. Paragraphs together make up sections, and sections make up the entire scientific paper or grant proposal. So let's begin by looking at the learning outcomes for this lesson. After this lesson, you will be able to explain how to structure a paragraph. You'll be able to explain the power positions in a paragraph, list examples of purposes of a paragraph, describe the characteristics of a good paragraph, define ideal sentence length, explain the power positions in a sentence, determine the correct subject and verb for a sentence, structure sentences in parallel structure, and finally explain ways to ensure paragraph coherence. So we're going to cover a lot of information in this lesson. I think you're going to enjoy it and hopefully learn some things that will make your writing better. Let's start off with paragraphs, and then later in the lesson we'll get to sentences. So what is a paragraph? It might seem obvious to you that a paragraph is a collection of sentences and that a paper is made up of a bunch of paragraphs. But there's more to it than that. A paragraph is more than a collection of sentences. A paragraph is an organizational tool. Paragraphs are going to be the units that lead your reader through your thought process, step by step, section by section. So if you start thinking about them in terms of organizational tools, that's going to help you structuring your paragraphs. So what is the structure of a paragraph? Ideally, a paragraph will begin with a topic sentence, and then it's going to go through a few sentences of development, and then it will have a conclusion. So topic, sentence, development, conclusion. Let's break that down a little bit more. A topic sentence is the first sentence of a paragraph that's going to let the reader know what the paragraph will be about. In other words, it's going to set the expectations for that paragraph. When you get into the development sentences, you'll have supporting arguments, and these will go into greater detail than the topic sentence goes into. They're going to allow you to elaborate on theoretical points and or on your reasoning for making the assertions that you're making. Then you should have some sentences that give evidence or examples. So support your arguments by citing figures or tables if you're in the results section, or cite previous publications as support or examples. The last sentence should be a conclusion that wraps the paragraph up and pulls it together. It's not a summary. It's a conclusion. It's not a summary. So it's not going to summarize what you said in the paragraph. Rather, it's going to advance the logical development of your paper and advance the overall goal of the paper. Let's look at an annotated example of a paragraph. So I'm going to show you a paragraph, and I'm going to label the parts of this paragraph. Okay, so first I'm going to read the paragraph to you, and then we'll go back through it. So it says, a major challenge for the extracellular vesicle field is being able to demonstrate in vivo EV transfer between cells. To address this problem, a few groups have recently developed clever modifications of EVs, allowing tracking of their behavior and their target cells in vivo. Figure 2. Either proteins or mRNA cargoes of EVs have thus been modified. For instance, fusing a fluorescent protein to a polymethylation sequence induces its localization at the plasma membrane, as well as in secreted EVs of all sizes. The EVs could then be visualized in the tumor microenvironment by intravital microscopy on animals bearing tumors expressing this fusion protein. Fusion of luciferase to a protein transmembrane domain also allowed its secretion in EVs and subsequent enzymatic measurement of luciferase activity in distant cells. These authors also designed an intracellular probe to fluorescently label mRNA secreted in EVs and tools to measure EV-borne mRNA encoding luciferase signal. While these tools are promising, studies so far have only demonstrated EV-borne mRNA transfer between cultured cells in vitro. So in my opinion, this is a very good example of a nice paragraph that follows the formula for structuring a paragraph. It has a topic sentence. A major challenge for the extracellular vesicle field is being able to demonstrate in vivo EV transfer between cells. So that topic sentence lets you know what this paragraph is going to be about. And every sentence in the paragraph should reflect back to that topic sentence. And in this paragraph, it does. So they did a nice job. Then, after that topic sentence, they developed their key idea, and that's highlighted in gold here. And then they gave examples and evidence. Those are the sentences highlighted in red. Now, I took out the references for ease of reading, but the authors did cite references here. And then they have a nice conclusion. So the conclusion is wrapping the paragraph together by saying, while these tools are promising, and then it's looking forward by saying that studies so far have only demonstrated EV-borne mRNA transfer between cultured cells in vitro. So by reading that conclusion, you see that they're both wrapping this paragraph up and they're looking forward into what's going to come in the next paragraph. It's probably going to be something about how these tools can be used in other ways to advance the EV field. So that was an example of a very nice paragraph. There are different ways that you could organize your paragraphs. As you're walking through the different sentences, depending on what you're trying to accomplish with that paragraph, you might order the sentences in different ways. For example, you might order them chronologically, or you might go from most to least important, from general to specific, from familiar to unfamiliar, or from simple to complex. So as you're writing your paragraphs, think about what you're trying to accomplish with that paragraph, and that will help you decide how to organize the sentences within it. Within a paragraph, the first sentence and the last sentence are considered the power positions. So this is where you should put your most important points, in that topic sentence and in that conclusion sentence. So if we go back to that example paragraph and just read the first sentence and the last sentence, we can see that they're talking about the major challenge and that it has not been accomplished yet. So it holds together rather nicely. What about length? How long should a paragraph be? Maybe you learned in school that there's a 5-sentence paragraph. Does that mean all paragraphs should be 5 sentences? No, it does not. There's really no minimum or maximum length for a paragraph as a hard and fast rule. But I would suggest that you avoid very short paragraphs. So 1 or 2 sentence paragraphs are probably too short. Maybe occasionally you could get by with that, but in scientific writing that's typically too short. And you should probably avoid very long paragraphs. Once you get to 200 or 250 words, you're probably going to be better off to break that into 2 different paragraphs. It's best if the paragraphs vary in length. If every paragraph is exactly the same length, it becomes a little bit strange for the reader. It becomes kind of monotonous and predictable. I wouldn't spend a lot of effort on trying to intentionally make the paragraphs different. I think that's naturally going to happen. But if you notice that your paragraphs are turning out pretty much all the same length, you might go back and edit them to make a little bit of variation there. Now, one of the things we want to talk about is the purpose of a paragraph. We already talked about the purposes of writing, but within the writing itself, we can have purposes for different paragraphs. So some examples of purposes of a paragraph include narration. So you might be reporting related events to tell a story. You might be describing something or some event. You might be comparing different things or different outcomes. You might be arguing, or in other words, developing a logical position, such as a hypothesis or a conclusion. It might be a paragraph to evaluate something by drawing conclusions about whether it was successful or not successful, looking at different limitations, different applications for various technologies. Or you might have a purpose to synthesize information by combining elements of previous topics to present a new perspective. And there's a good chance that different paragraphs within your introduction, within your results, within your discussion will have different purposes. Now, that example I showed you earlier, I said that that was a good paragraph. There are some reasons that it was a good paragraph beyond the fact that it had a topic sentence and a conclusion, and it had development in the middle. So let's look at characteristics of a good paragraph. It's going to have 4 characteristics. Unity, coherence, and development are 3 that you will notice within an individual paragraph. And then distinctness you only notice when you're comparing paragraphs to each other. All right, so let's go through these. Unity means that the entire paragraph should be focused on one topic, and that topic is laid out in the topic sentence. So the paragraph might have several points, but all of the points should be related to that one topic that's laid out in the topic sentence. If you have paragraphs that have multiple topics in them, readers are going to become confused and they won't really understand what you're trying to tell them, or it just won't feel unified. Now, coherence means that the sentences should logically connect to each other and build on one another. And so the paragraph is moving logically as you read through the sentences. They're flowing one to the next. Development means that the paragraph should advance your overall scientific story by explaining your reasoning and supporting it with specific details. It should move your manuscript forward toward its overall goal. And so that's what we see in those middle sentences of a paragraph. Distinctness, as I mentioned, is something that you will only notice when you read an entire section and you're looking at different paragraphs. And you ask yourself, are these paragraphs covering the same topic? You should not have that. You don't want to have repetitiveness. The first paragraph in the discussion section should not be covering the same information as the third paragraph in the discussion section. You need to advance as you go through the paper. All right, so let's get into some examples of paragraphs. We'll look at some examples that are good and some examples that could be improved. We'll start with unity and coherence. So here is a paragraph. I'm going to read it to you, but if you'd like, you could also pause the video and read it by yourself if you want more time. The n-drop platform encapsulates cells into droplets with lysis buffer, reverse transcription RT reagents, and barcoded oligonucleotide primers. mRNA released from each lysed cell remains trapped in the same droplet and is barcoded during synthesis of cDNA. After barcoding, material from all cells is combined by breaking the droplets, and the cDNA library is sequenced using established methods, CellSeq. The major challenge is to ensure that each droplet carries primers encoding a different barcode. We synthesized a library of barcoded hydrogel microspheres, BHMs, that are co-encapsulated with cells. Each BHM carries approximately 109 covalently coupled photoreleasable primers encoding one of 147,456 barcodes, and the pool size could be increased in a straightforward manner. The current pool size allows randomly labeling 3,000 cells with 99% unique labeling. Many more cells can be processed by splitting a large emulsion into separate tubes. So what do you think about this paragraph in terms of unity and coherence? Do you think it's a good one? I hope you said yes, because I think it's a good one. I think it's a very good paragraph. Now I'm going to highlight some of the key terms that are used in this paragraph. All right, the first sentence is the topic sentence, and it has key terms like droplets, lysis buffer, RT reagents, barcoded primers. So as we read through the following sentences, we see mRNA released from each lysed cell. That phrase lysed cell reflects back to the topic sentence. So does droplet, so does barcoded, barcoding cells, droplets, primers, barcode, co-encapsulated cells, primers, barcode cells. And so you can see that each sentence is unified. It is reflecting back to that topic sentence using the same terms. Maybe slight variations of those terms, but those terms are all recognizable. I also feel like this paragraph has very good coherence because it is moving forward. It's going step by step, and it's describing the process of them developing this new technology. So I really like this paragraph. Some common problems that we see in paragraphs are as follows. Sometimes the first sentence is not a topic sentence. Sometimes you'll see that the first sentence, instead of being a topic sentence, it's referring back to the previous paragraph. Now this is a problem because it doesn't set up the paragraph to be one contained unit. That paragraph is relying on the reader to either remember the previous paragraph in a very specific way that's hard to do, or it's requiring the reader to go back and reread part of that previous paragraph. And that's not a good thing to ask your reader to do. Another problem when the first sentence is not a topic sentence is maybe it's referring to another published idea. So it's citing a reference in that very first sentence and referring to that. Well, that's a problem because you have to know what's in that reference, or you have to go and read that reference on your own. So that's a lot of work for the reader. Or this paragraph might start with other information, that there is a topic sentence, but it's not the first sentence. It's interrupted with this other information, such as a definition, a caveat, or a concern. Another common problem in paragraphs is that a paragraph contains more than one topic. In other words, it's going to lack unity. And we'll see some examples of that. Another common problem is that the paragraph is not coherent. So there's a lack of logical flow, moving from idea to idea, or the paragraph just ends. It doesn't have a conclusion that wraps the paragraph together and advances the argument. It just ends abruptly. Let's look at another paragraph, and we'll analyze this paragraph and think about whether it can be improved by addressing some of these characteristics of good paragraph, of unity, cohesion, and development. Because plastids are required for photosynthesis, the production of major phytohormones, and other metabolic processes, they are in a key position to sense alterations in the environment and communicate accordingly to the nucleus. So that first sentence should be a topic sentence. I don't know what this paragraph is going to be about. This sentence covers a lot of ground by itself. It opens up with this phrase, because plastids are XYZ, they are in a key position to sense alterations in the environment and communicate accordingly to the nucleus. It makes me think that it's going to be talking about plastids sensing alterations in the environment. But at the same time, it also makes me think that it's going to be about plastid function, because it says plastids are required for photosynthesis, the production of major phytohormones, and other metabolic processes. So it's a bit confusing what this sentence is about and what the paragraph is going to be about. I don't feel like that's a very clear topic sentence. Now, if we move on into the paragraph, it says, for example, light quality affects the plastid transcriptome, while light quantity affects plastid signaling, and both influence photomorphogenesis. So light quality is something at a given time, and light quantity is going to be a quantity at a given time. So these are not alterations in the environment. They're the state of the environment. So this is, to me, not unified with the topic sentence if the topic sentence is about sensing alterations in the environment. So they are describing plastids sensing the environment, but not sensing alterations in the environment. Now, the third sentence says plastids also play a role in tolerance and signaling against drought, freezing, heat, and oxidative stress. So that could be reflecting back to the topic of sensing alterations in the environment. But let's keep going. Furthermore, disruption of regulators of plastid function, such as pentracopeptide repeat proteins, can lead to defects in growth, embryo development, photosynthesis, and leaf pigmentation, among others. So that is not reflecting back to anything in that first sentence. It's a completely different topic coming in, pretty much out of nowhere. And then the final sentence says, as such, the status of plastids has a profound level of control over the entire plant, including its responses to environmental and cellular stress. So that might be a decent concluding sentence. Maybe the problem with this paragraph is that it's missing the topic sentence. So I think that first sentence has too much going on. It should be broken up, and there needs to be a topic sentence for this paragraph. I feel like it's not very unified, and also because some of these sentences that follow each other are making big turns in direction of logic. Some of these sentences that follow each other are not developing an idea. They're just listing different ideas that are not even connected to each other. So coherence is not really there either. So I would say that this paragraph has a lot of great ideas in it, but I think it needs to be reworked to make it into a great paragraph. Okay, let's look at another example paragraph. This one starts out with the sentence, biopharmaceutical manufacturing represents nearly 2% of the U.S. GDP, which makes it an important driver of the U.S. economy. Naturally, I'm going to assume that that's the topic sentence. So I expect that this paragraph is going to be about the economical impacts of biopharmaceutical manufacturing and how it contributes to the U.S. gross domestic product, GDP. The second sentence says, biopharmaceuticals include monoclonal antibodies, recombinant proteins, and assemblies of proteins produced by biological means. Commercial products are used as blood factors, thrombolytic agents, therapeutics, growth factors, interferons, and vaccines. So already those second and third sentences have nothing to do with the economic aspects of biopharmaceutical manufacturing. So the first sentence is not a topic sentence. We can see that. Clearly the paragraph is still about biopharmaceuticals, but it's not really about the economy. Now let's continue. The most common mammalian cell line used is the Chinese hamster ovary, CHO line, due to its ability to produce biopharmaceutical molecules with post-translational modifications required in humans. So that sentence did not follow logically from the preceding sentences. So the way it started off, the most common mammalian cell line used is the CHO line. How does that connect to biopharmaceutical manufacturing? So they needed to work those terms into that first part of the sentence. Paragraph continues, however, it is well understood that recombinant CHO cell lines are susceptible to genome instability that is often observed after approximately 70 generations. So now we've got a new topic altogether coming into this paragraph. It's talking about genome instability. That has nothing to do with biopharmaceutical manufacturing in the economy. So we've completely changed topics in the middle of this paragraph. And then it goes on, I'm not going to read all the rest of it, but it develops that idea about genome instability. What we have here is really three different ideas that are crammed into one paragraph. So the biopharmaceutical manufacturing, I think what they were trying to accomplish with this talking about the economy is the significance of biopharmaceutical manufacturing. So a different topic sentence would have made the first part of this paragraph more unified. Now, once they started talking about Chinese hamster ovary cells, that really should have been a separate paragraph. So this paragraph is not doing that great in terms of topic and coherence. It's doing okay in terms of development, but the ideas are not flowing logically. All right, so let's now look at sentences. We've looked at paragraph structure. Now let's look at sentence structure. And then we'll come back and combine the ideas on sentences with the ideas on paragraphs. So how long should a sentence be? When we asked this question about paragraphs, we said there's really no hard and fast rule. Well, with sentences, it's a bit more clear. I suggest that you write short sentences and use simple words in those sentences, as we've talked about in previous lessons. But how long is a short sentence? So for scientific writing, I suggest you aim for sentences with an average length of between 18 and 23 words. So if you get your final readability score and you have an average sentence length of 23 down to 18, good job. That's where I want you to aim. And that should help you get into that 30 to 50 flash reading ease score range. You can have some sentences that are longer than 23 words. Just average them out by having a higher number of shorter sentences. So we talked about writing simple sentences. Now let's talk about sentence complexity. Most sentences should be limited to one idea. So keep one idea per sentence. If you find your sentences have more than one idea, the best thing to do is to break it up into 2, sometimes 3 different sentences. Just like in a paragraph, you've got power positions in a sentence. And just like in a paragraph, they're at the beginning and the end of the sentence. At the beginning of the sentence, just like a paragraph, this is the topic position. And this is where you want to place old, familiar, or short information. Now, when you have new, complex, or long information, it's better to put that at the end of the sentence in the stress position. One tip I would like to share with you is to make sure that you make the intended topic of the sentence the grammatical subject of the sentence. So what do I mean by that? Let's look at some examples. Here's a sentence where the subject is the author and year. So the subject is the reference and the verb is observed. Manshadi et al. 2006 observed that a drought-tolerant wheat genotype had more compact root architecture and a greater root length density at depth than a sensitive genotype. So do you think the authors really intended for the reader to take away from the sentence that Manshadi et al. Observed something? Is that the intended topic? No, I don't think so. I think the intended topic is about the drought-tolerant wheat genotype. Or it could be about the more compact root architecture and the greater root length density at depth. So either way, what I would like these authors to do is to move the most important part of the sentence to that topic position and make it the subject. So revision 1 is a drought-tolerant wheat genotype had more compact root architecture, etc. And then the reference comes at the end. Or revision 2 is more compact root architecture and greater root length density at depth was observed for the genotype. It's also important in your sentences to use parallel structure when you have compound sentences or you have phrases within the sentence. They need to be structured in the same way. What is parallel structure? Parallel ideas are ideas that are in a sentence that are equal in logic and importance. So this would be a compound sentence where the ideas are joined by a conjunction like and or but or however, or they are ideas that are being compared. Similar parts of a sentence should be written with a similar structure. So use the same tense, the same voice, the same verb forms. Let's look at some examples of parallelism. So an example of a sentence that is not in parallel structure would be traditional small molecule inhibitors inhibit the enzymatic activity of the target, while the enzymatic activity of the protein and also non-enzymatic activity are affected by PROTACs. So why is that non-parallel? In the first part of the sentence, the first clause, traditional small molecule inhibitors is the subject and inhibit is the verb. Now in the second part of the sentence, it says the enzymatic activity of the protein and also non-enzymatic activity are affected. So you have a different verb structure and you have a different way of setting up the subject. So the first one is active. Inhibitors inhibit. And the second one's, and it's a state of being type of verb. So to make it into parallel structure, traditional small molecule inhibitors inhibit the enzymatic activity of the target, while protacts affect the enzymatic activity of the protein and also its non-enzymatic activity. Let's look at another example of parallel structure. The not parallel version is the flexible C-terminus of UB protrudes from the UB fold, and its termination is with an essential glycine. Now, if we make that parallel, it says the flexible C-terminus of UB protrudes from the UB fold, and it terminates with an essential glycine. So it's a subtle difference, but it is an important difference to make sure that the structure of the second part of the sentence is the same as the structure of the first part of the sentence. A similar idea to parallel structure is the comparison. We want to make sure that we avoid faulty comparisons or incomplete comparisons. For faulty comparisons or ambiguous comparisons, make sure you only compare like with like. So here's an example of a sentence that says, in the US, it is estimated that 13.8 million people will be suffering from AD by 2050. On the other hand, the prevalence of the disease in Malaysia is estimated to reach 0.54% by 2050. All right, so this is a comparison that is ambiguous. I would even say it's faulty because you're comparing number of people in the US with percentage of people in Malaysia. And so the only way to know how those numbers compare is if you go and look up the population of the US and look up the population of Malaysia and do the conversion yourself. They should either both be numbers of millions of people or they should both be percentages of populations. Another example is here. The way that it's not a good comparison is to say both of our catalysts under cycling conditions revealed a similar stability compared with Wu et al. So what's wrong with saying that? The problem is they're comparing the catalysts with Wu et al. Those are people. People are not catalysts under cycling conditions. They're comparing their results to people. So the way to fix this sentence is to say both of our catalysts under cycling conditions revealed a similar stability compared with stability determined by Wu et al. So now we're comparing like with like. So here's an example of an incomplete comparison. Henry et al. 2011 found a rice genotype with deep root growth exhibited greater drought resistance and highest drought resistance index. So the question is, greater drought resistance than what? And highest compared to what? So we need to add that information to make this a complete comparison. And also we've got the authors as the subject of the sentence. So I would also change that in my revision. So my revision would be like this. A rice genotype with deep root growth had greater drought resistance than a genotype with shallow growth and had the highest drought resistance index of several genotypes. So we've added the information to complete the comparison. So we have discussed paragraph structure and we have also discussed sentence structure. And as you know, paragraphs are made up of sentences. Now let's talk about combining strategies for sentence structure with strategies for paragraph structure and how those two work together. Now we already talked about parallel structure for sentences, but we also need to think about parallel structure within paragraphs, not just within sentences, but within the paragraph itself. Like there are parallel ideas in compound sentences, there are also parallel ideas in a paragraph, and these ideas are equal in logic and in importance. So when you have multiple sentences that are exploring different angles of the same topic, different ideas within that same topic, make sure that you structure those sentences in the same way. So they're separate sentences, but you want to structure them in the same way so that in the reader's mind they're immediately comparable to each other. So use the same grammatical structure, the same word choice, the same word order, the same tense, the same voice and verb form, etc. And so when you use this parallel structure, it's going to make it much easier for your readers to see what you're doing and what you're thinking as you're writing these paragraphs. So here's an example of using key terms consistently within a paragraph. You need to use key terms consistently throughout your entire manuscript, but we're just going to look at one paragraph. Okay, so this paragraph says, "We report the discovery of a 50,000-year-old birch tar-hafted flint tool from northwestern Europe. It complements a small set of well-dated and chemically identified adhesives from Middle Paleolithic/Middle Stone Age contexts. Together with data from experiments and other Middle Paleolithic glues, it demonstrates that Neanderthals mastered complex paste production strategies and composite tool use at the northern edge of their range." Now we see here that in the first sentence they use the term adhesive, in the second sentence they use the term glue, and at the third usage they say paste. Now, you can probably figure out that they're talking about the same thing, adhesive, glue, and paste, but it takes you a little bit of extra time. You have to think about it, and you have to actually slow down your reading and think, wait a minute, is the glue and the adhesive the same thing, or is it something different? Is it something subtly different? And it takes extra effort on your part as a reader. So what I would suggest these authors to do is choose one of these terms and use it consistently. For example, just say adhesive each time. Now it's consistent. The reader doesn't even have to think about it for a split second. It's obvious that they're talking about the same thing in each of these sentences. Now let's talk about another strategy for making your paragraphs coherent. So remember, unity, coherence, and development are all part of a good paragraph. They're all components or characteristics of a good paragraph. So one way to ensure that the paragraph is cohesive is to use this technique that we call the jumping word position. If you remember, we had the rule to place old, familiar, or short information at the beginning of a sentence in the topic position, and we had the rule to place new, complex, or long information at the end of the sentence in the stress position. Remembering that, as you write multiple sentences to develop your ideas, use that to your advantage. So what is new information in one sentence now can become old and familiar information in the following sentence. So you can use this technique to string together sentences and develop your ideas very quickly in an efficient way within a paragraph. And it also makes the paragraph coherent because one sentence leads into the next. Let's look at an example. So this is part of a paragraph made up of 3 different sentences. The first one says, "While iron is usually abundant in soil, its solubility is low in alkaline soils, which are often calcareous and contain high concentrations of bicarbonate." And so in the green there we see the familiar information. Everyone is familiar with iron and they're familiar with soil, but they may not be familiar with alkaline soils and their characteristics. So that is the new information, which is in blue, and it's at the end of the sentence in the stress position. Now that the high pH alkaline soils have been introduced, then we can move on to make that familiar information in this second sentence, which starts out with that concept as its subject. Alkaline pH with high bicarbonate levels can cause iron deficiency chlorosis, a situation resulting from functional iron deficiency where leaves are yellow instead of green. And so we've introduced the new concept of iron deficiency chlorosis. Now that can become a familiar topic in the next sentence, which says, "However, beyond chlorosis, the biological effects of IDC are mostly unknown, especially at the molecular level, and it is not clear that IDC resulting from alkaline stress is equivalent to iron deficiency resulting from low iron supply." So I think you can see how to use this jumping word location technique to put your paragraphs together in a cohesive way. All right, so this next part, I want you to read a paragraph So after I describe this paragraph, I would like you to pause the video and read the paragraph and think about how it's organized and your feelings about the quality of this paragraph. So pause the video now and read this paragraph and then start the video again. All right, so I'm assuming you read the paragraph. What did you think about it? Now, when I've done this exercise in person numerous times during my teaching and during workshops, what I hear from the students is that they feel like the paragraph is disjointed. They feel like the information is jumping from topic to topic. They say it doesn't really make a lot of sense. It just seems like a bunch of facts that are strung together, which is true. And so this example paragraph is one that I took from a journal article, and I intentionally made it not very good. So the original authors didn't write it this way. I made it this way. And the way I made it like this is I took out all of what we call transitions, which are a type of meta-discourse. Transition phrases and transition words help the reader see the connections in logic as the authors are developing their ideas in a paragraph. Let me show you this paragraph in its original form with the transition words and phrases included. And I would like you to pause the video and read this paragraph again and see what you think about it now. So now how do you feel about this paragraph? Does it flow well? Is it developing in an efficient way and in a logical way? I think you'll say yes. Now this is a good paragraph. It makes sense. Even if you don't understand the science that they're talking about, the logical development of the paragraph makes sense. And so that's the power of using transition words and transition phrases. It links these ideas together and brings cohesion into the paragraph. And as I mentioned, transitions are a type of meta-discourse. Meta-discourse is a way of interacting with your reader, even though your reader is not there with you and your reader is not in the same time plane as you are. Let's look at some additional types of meta-discourse that you can use in your writing to make these logical connections to help your readers. So what we have here is a table of categories of meta-discourse markers with some examples. So we have things like logical connectives. Those include also, although, in addition, on the other hand. We have different types of frame markers such as sequencing, label stages, announcing goals, and topic shifts. And you can see examples of those in this table. We have what are called code glosses that include phrases like, for example, in other words, such as, that is to say, endophoric markers which link different parts of the manuscript to each other, such as discussed above. Then we have evidentials, which are transitions to connect to evidence. And then we have interpersonal meta-discourse, such as attitude markers, hedges, relational markers, person markers, and emphatics. Attitude markers are going to show how the author is feeling about what they're saying. Things like hopefully, importantly. And you want to be careful with the attitude markers in scientific writing because, remember, you don't want to inject your personal opinion into any kind of technical writing. So things like hopefully and unfortunately, when I'm editing scientific writing, I prefer to take those out. It's okay to indicate the level of importance or the level of certainty of your ideas. So you can use attitude markers for that. Hedges, you want to be careful using hedges because it can indicate that you're not very confident about the topic. And remember, as a technical writing author, you should be an expert and you should be confident in what you're saying. You can use hedges when you need to indicate that you're not entirely certain about something, but try to be as certain as you can be in scientific writing. And with the emphatics, again, I would recommend being very cautious using these in scientific writing. Usually when I see emphatics like clearly, actually, certainly, in fact, and must, a lot of times they're being used in a way that I feel like they're trying to manipulate me as a reader. And they're trying too hard to convince me about something instead of letting the data and the results speak for themselves. Overall, I do recommend that you use meta-discourse markers in your writing to help the readers follow your thought process. Now I would like to show you a graphical representation of paragraph structure. So let's try to put all this together, represented in a graphical way. What we see are two full paragraphs and the beginning of a third paragraph. Now I'll let you pause the video for a few seconds and try to figure out what each of these different parts is referring to. All right, did you figure it out? I think you probably did. So the first line, which is the dark green line, that represents the topic sentence. And each of the following lines is pointing back to that topic sentence because each of the sentences in a paragraph should relate to that topic sentence. The green circles within the paragraph are representing these meta-discourse markers or transition phrases that are going to help with coherence in linking the sentences in the paragraph to each other. And the green final line, that represents the conclusion sentence, which is not only wrapping up this paragraph, so it's pointing back to the topic sentence, but it's also pointing to the topic sentence of the following paragraph because within the conclusion sentence it should be looking forward and giving the reader some idea of what's going to come in the next paragraph. So it can act as a transition itself. And then when we see the second paragraph topic sentence pointing back to the first paragraph topic sentence, this is looking at coherence between paragraphs within a section. So if you take all of the topic sentences and pull them out of your paragraphs and just look at them in isolation, you should see a logical progression. And the topic sentences should logically relate to each other. The first topic sentence in a section is going to be kind of a master topic sentence that tells what's going to happen in that entire section. And that's why the topic sentences in the second and third paragraphs are pointing back to the topic sentence in the first paragraph. Okay, so we have reached the end of this lesson. I would like to wrap it up by just revisiting quickly the learning outcomes for this lesson. And so again, after you complete this lesson, you will be able to explain how to structure a paragraph. You'll be able to explain the power positions within a paragraph, list examples of purposes of a paragraph, describe the characteristics of a good paragraph, define ideal sentence length, explain the power positions in a sentence, determine the correct subject and verb for a sentence, structure sentences in parallel structure, and explain ways to ensure paragraph coherence. I hope this lesson was helpful. Put it into practice as soon as possible, immediately. If you don't have any writing to practice on, or you want additional practice, just go out into the literature at random, grab some papers, copy and paste it into a Word document, and start practicing these editing techniques on that writing. And as you're doing it, happy writing. Hello, scientific writers. Welcome to the next lesson. This lesson is on words and punctuation with a punch. So we'll be talking about word choice, and we'll be talking about correct punctuation in scientific writing. Let's begin with the learning objectives or the learning outcomes for this lesson. It's going to be a shorter list this time. After you complete this lesson, you will be able to recognize common errors in sentences. You'll be able to explain why they are errors, and you'll be able to correct common errors in sentences. What kinds of common errors are we going to be looking at in this lesson? So we have a pretty substantial list of common errors, and each of these I'm going to have 3 or 4 examples. Here's the list of technical writing skills that I'll be talking about in this lesson. The first is using precise terms and providing enough information. Secondly, using simple words over complex words. And we've mentioned this a little bit in previous lessons, but we'll go into it again here. We'll look at avoiding using cliches, colloquial expressions, jargon, and buzzwords. We'll make sure that it is clear which noun your pronoun refers to. We'll look at something I call don't do this alone. We'll talk about using articles correctly, careful word choice, deciding whether to use that or which, avoiding substituting one part of speech for another, making sure your words are in the correct place in a sentence, looking at how phrase order determines emphasis, We'll watch out for missing or extra words, and we'll talk about countable and uncountable nouns, missing commas, unnecessary commas, eliminating the comma splice, and looking at how semicolons should be used. And we'll talk about the importance of avoiding errors in spelling, punctuation, and grammar. So there's a lot to cover in this lesson, but it's all good stuff and you can put it into practice immediately. All right, let's get started with the first topic. Make sure to use precise and simple wording. Let's start by looking at some examples of writing that is not precise enough or does not provide enough information to be precise. So an example of a sentence that is not precise enough or does not have enough information is shown here. After blocking with BSA, the microtissue was held overnight in the cold with an antibody for sarcomeric alpha-actinin. So what's wrong with this sentence? Now, we're assuming this is in the materials and methods section of your publication or the approach section of a grant proposal. The phrases that are not precise enough are underlined here. So after blocking with BSA. So what do we need to know? We need to know the concentration of the BSA, and we need to know how long the blocking was done. So we need to add that information. The microtissue was held overnight. Well, how long is that? Let's be more precise. Is overnight, from midnight to 6 a.m., or is it from 5 p.m. to 9 a.m.? How many hours are we talking about? It says in the cold. Well, what does that mean? Is cold 40 degrees Fahrenheit, or is it in a freezer? So let's be more precise about that and give an exact temperature. With an antibody for sarcomeric alpha-actinin. So what is this antibody? At what concentration was it used? What supplier did it come from? Because different antibodies from different suppliers may not perform in the exact same way. So it's important to provide that information. So we see in the revision, they have this information. So after blocking with 3% BSA for 1 hour, the microtissue was incubated for 16 hours at 4 degrees C with a primary antibody at 1 to 100 from Sigma Aldrich. So now we have enough information that another scientist could repeat this procedure, and we have enough information for reviewers and readers to evaluate whether they feel like the work was done properly. Now let's talk about using simple words. And I'm going to show you one example here. Members of Burkholdera were enriched in the rhizosphere, possibly due to their versatile abilities to utilize root metabolites, degrade aromatic compounds, and produce antimicrobial substances. Well, why say utilize, which is a 3-syllable word, when you could just say use, which is a 1-syllable word? So remember, readability is partly dependent on polysyllable words, syllable words. So anytime you can use a 1-syllable word instead of a 3-syllable word, you're going to increase your readability scores. So just change utilize to use. Simple. Additionally, for using simple words over complex words, let's look at this example. It says, interestingly, rice possesses a much higher number of ammonium transporter genes than Arabidopsis and tomato, while, with regard to nitrate transporters, their number appears not to be higher in rice compared with Arabidopsis and tomato. Possesses is a 3-syllable word, and it seems awkward to say that a plant possesses something. Possessions are like, your computer, your car, your book collection. Those are possessions. Rice doesn't really have possessions, but it has properties. So let's change possesses to has. And then instead of saying this long phrase, a much higher number of, why don't we just say more? Rice has more ammonium transporter genes than Arabidopsis and tomato. And we don't need this phrase with regard to nitrate transporters. Let's just talk about the number of nitrate transporters. And instead of saying appears not to be higher, let's change appears to something more certain with a higher degree of certainty. So is. The number of nitrate transporters is equal or smaller in rice, Arabidopsis, and tomato. And I took away compared with. That's not necessary. So I made quite a few edits to this sentence to make it more simple with the words that are used, and also to make it shorter by eliminating some phrases that are really not that necessary to get the meaning across. Let's look at two more examples, and I'm going to show you on this slide both the original and the revised version at the same time. So what we see here is the first sentence says, a simple isotope mass balance was utilized to quantify the contribution of atmospheric nitrate deposition to the water column. Utilized, to use, we already talked about that. So anytime you see the word utilized, I think 99% of the time you can say use instead of utilize. And it makes the exact same meaning, and it's a better, more readable word. And then quantify. Quantify is a 3-syllable word, whereas measure is a 2-syllable word. So let's change quantify to measure. And they mean the same thing. Why say quantify when you can say measure? So if we make those two simple changes, we've reduced the number of syllables in this sentence, so it's going to increase the readability score. And the next example, after 30 minutes, heterotrophic bacterial cells possessed the overall highest N15 to N14 ratios. So again, I feel like bacteria possessing something is, a little bit awkward. And again, that's a multi-syllable word when we could just say that after 30 minutes, heterotrophic bacterial cells had the overall highest ratios. We don't need to use this fancy word possessed. We can just say had. Now I have a downloadable for you on the course website that is a table of complicated word examples where we can substitute complicated words for simple words. Let's look at one more example of simplifying a sentence with using less complicated words. The original sentence is on the left here. It says, consequently, the abundance and composition of micro-sized plankton comprise necessary information for evaluating the biological productivity of the ocean. Great information there, but I think we can simplify the wording to increase the readability. So consequently, we could substitute with thus. So we're going from a 4-syllable word to a 1-syllable word. That immediately makes the sentence more readable. And we could, instead of saying abundance, say amount. Sometimes abundance might be a little bit more precise than amount, but in a lot of cases you could go with the word amount. So the amount and composition of micro-sized plankton. And instead of saying comprise necessary information for evaluating the biological productivity, I would suggest thinking about what that phrase means and rephrasing it in a more concrete way. So we talked about concrete and abstract last time. I think we can just change this entire phrase to say that the amount and composition of micro-sized plankton is needed to evaluate the biological productivity of the ocean. The next topic we need to talk about is avoiding using cliches, colloquial expression, jargon, and buzzwords. Cliches are sayings that are common in the English language, but they're just too common. They're overused and they're not very precise. Colloquial expressions are things that you would say in a conversation to your friend, but they're really not appropriate for technical writing, which, as we've learned, has a formal tone to it. Jargon would be words that are highly specialized and they're only familiar to a very small group of people that already know these terms. So they're inherently exclusionary. Now, I realize that you have to use specialized terminology. I consider jargon to be overly specialized terminology or terminology that is not really the official terminology, but it's something that the group calls something amongst themselves. And then buzzwords are the words that are hot at that particular time. And after a few years, those buzzwords are going to be replaced by different buzzwords. And so they don't hold up over time. You want your writing to hold up for decades or even hundreds of years. Since these terms are imprecise and ambiguous, when you use them, you run the risk of not understanding your meaning. So I suggest you don't use those. Let's look at some examples. So one would be the successful reformation of bone and cartilage remains an unsolved riddle. So unsolved riddle, this is kind of a colloquial expression. The next one uses the phrase, just the tip of the iceberg. So this is a cliche. A lot of people know what it means, but it's really not the formal tone that we like to see in scientific writing. The next example says the mitotic cell population was then harvested by shakeoff and subjected to Western blot analysis. Well, shakeoff is one of these jargon terms. It's probably used by people in this lab, but I don't know what it means. It implies that you're shaking something to get the liquid off of it, but I don't really know if that's what it means. This is kind of a jargon, colloquial combination term, and I would suggest replacing it with something that's more precise. The last example here, we further observe how the three models affect the evolution of cooperation by taking a snapshot of the network after the evolution stabilizes. So taking a snapshot is, again, kind of a colloquial expression. It's not very precise, and it's not literal, of course. You don't take a camera and take a snapshot of the evolution network. So they should think about a way to word it that is more precise and technically accurate. One more example for you. This is one of the current buzzwords here in 2021. It's been around for a few years, but it's still around. Natural products interrogate a different and wider chemical space than synthetic derivatives. So using this word space is a current buzzword. So what do they really mean? Natural products interrogate a different and wider range of compounds than synthetic derivatives. That's what they mean. So instead of saying space, I would suggest something like that. The next topic we can talk about is to make sure that it is clear which noun your pronoun refers to. So we want to avoid having unclear pronouns. And unclear pronouns happen when a pronoun could refer to too many possible nouns, more than one possible noun in that sentence that a pronoun could refer to, or if there are no possible nouns that the pronoun could refer to. Let's look at some examples. In this sentence, it says, flying foxes ceased to function in dispersing large seeds long before they became rare. All right, so they is the pronoun, but what became rare? Are we talking about the large seeds, or are we talking about the flying foxes? So there are two possible nouns upstream of that pronoun. It's not really clear the way the sentence is written which one of those nouns the pronoun is referring to. In another example, it says these two genes are involved in brain growth and development as several mutations result in microcephaly, and they seem to have played an important role in the evolution of the brain. They could refer to either genes or mutations. It's not really clear to me. And I recognize that the mutations that they're talking about are in those genes that they're talking about. But at the same time, is it the genes themselves that contributed to evolution, or is it the mutations that contributed to evolution? It's not clear to me the way that this sentence is written. Now, when we're referring to no possible pronouns, that is what I call doing this alone. The word this must always be followed by a noun so that its reference is specific. So you shouldn't say something like, this is a fast reaction, this leads us to conclude. Rather, you should say, this reaction is fast, or this observation leads us to conclude. So don't do this alone. Here are some examples. Examining this in more detail, we found that animals displayed strong fast avoidance of monoxeniclons. This suggests that cells may regulate the structure of the cytoplasm and enter into and exit from a metabolically inactive state. This is especially true for studies that use commercial seed production fields at the landscape level. So the problem with doing this alone is not just that you don't know what the pronoun is referring to. It's also that you're asking your reader to either remember what they read previously or forcing them to go back and reread it to figure out what the word this is referring to. And a lot of times when I find this alone in writing and I try to go back to see what the this is referring to, there's really nothing there that it refers to. Even if I go back and read the previous sentence or two, there's nothing there that's a specific noun. It might be an entire phrase. So make sure that you don't do this alone. The next topic we're going to discuss is using articles correctly. As you recall, there are three articles, a, an, and the. A and an are indefinite articles, which means they do not refer to a specific noun, and the is a definite article because it refers to a known or specific noun. And also recall that a and an are only used before singular nouns. They're not used for plurals. Now, I recognize that articles are a difficult part of the English language, especially for those of you who grew up speaking a different language and you learned English later. It's beyond the scope of my course to go into all of the rules. There are quite a few rules about using articles, but I do want to emphasize that it is important to use them correctly because it changes the meaning of sentences sometimes, and even if it doesn't change the meaning of sentences, it gives a bad impression to reviewers if your articles are not being used properly, and they might give you a hard time, which is really not fair, but that's the way it is. So let's look at some examples of how to use articles and how not to use articles. So we have 3 example sentences here. Stresses can be present in combinations such as the simultaneous heat and drought. The original sentence had the article the, but it shouldn't be there. So we should just say such as simultaneous heat and drought. These nouns, the way this sentence is structured, they don't require an article. In the second example, condensin 2 also localizes to chromosome axes during the early prophase and may play a primary role in the formation of the chromosome scaffold. So the authors had an extra the in the first line there during the early prophase. So you don't need the article for early prophase. But they were missing the second article, the formation of the chromosome scaffold. So we do need an article in front of formation. The third example is shown here. The formation of lakes is an evidence of the abundant geological activity that constantly shapes and reshapes the physical structure of the earth. We should not use an article for evidence. So if we did need an article, an is the correct one. However, evidence is the kind of noun that does not require an article because it's uncountable. So the formation of lakes is evidence, not an evidence. You can't have multiple evidences. So we don't need that singular article. And then in terms of earth, this one is a little bit tricky because it is true that proper nouns like earth don't require articles. However, in the English language, we typically refer to certain things with articles, like the earth and the University of Nebraska. By the rules, it shouldn't require an article. We tend to do that anyway. And if you leave out the article, it doesn't sound right to the ear. And so we need to include that article for things like the earth. Now let's talk about word choice. It's important to be careful with word choice. Here are some examples of why that's important. It's not correct to say the rainfall affected the fluorescence intensity of all components. You should say the rainfall affected the fluorescence intensity of all components. Effect and affect are 2 words that are commonly confused. So look for other commonly confused words and make sure that you're choosing the correct word. The second example is an example of an ambiguous word choice. Pepper capsicum species has a cosmopolitan distribution and considerable economic importance. Now, technically, cosmopolitan is not wrong, but cosmopolitan is a word that has a lot of different meanings. And in the United States, cosmopolitan is typically used to mean something associated with cities or culture, worldliness. Someone who travels the world is considered to be cosmopolitan. Somebody that likes to go to Paris and London and Tokyo and fancy cities like that, we refer to them as a cosmopolitan person. Using that word to describe a plant, although it's correct because one of the meanings of cosmopolitan is distributed worldwide, it's correct, but it's ambiguous because of all of the other meanings of cosmopolitan. So I would suggest that the authors just say pepper has a worldwide distribution and that would not be confusing to readers because it's a lot more direct. So some other examples of word choice are where the meaning is just not quite right. It's a little bit different than confused terms like affect and effect, but when the meaning is just not quite right. So this example says, this result suggests that the river acted as a geographic barrier that avoids gene flow between populations in the east. So avoid is not quite the right word here. We should use the word prevents. So the difference between prevent and avoid has to do with the agent and the intention. So make sure that you're choosing words that have the correct meaning in that context. A few more examples here. 7 genes representing transcriptional regulators. It would be better to say 7 genes encoding transcriptional regulators. That's more precise. The next example, many studies are conducted based on a drug repurposing strategy to rapidly identify an effective drug from existing ones. Well, the studies are not based on this strategy, they're using the strategy. You would only say they're based on the strategy if the researchers doing these studies took the original strategy and modified it to make a different strategy. That's not what this sentence says. It would be better to say many studies are conducted using a drug repurposing strategy. Another word choice that you're going to be faced with is using the word that or the word which. And sometimes it's hard to know which of those two words is the correct one. So I'm going to give you some tips for figuring this out. Now note that these tips are for American style English. The British style English is a little bit different. They tend to use which all the time in the situation that the American style English would choose the word that. So what are these guidelines? That should be used with a restrictive or defining clause. So that is a clause that gives essential information. Which should be used with non-defining clauses that provide additional information, but this additional information is non-essential. And also you need to use a comma before which. Those are a couple of different ways to figure it out. Let's look at some examples. So in the first sentence, this is not the correct word choice. It says low water availability decreases flower production that negatively impacts the resources provided by the plants to the bees. So what you can do is look at the sentence without the phrase in question and see if it makes sense. So if we just said low water availability decreases flower production, that makes sense. That's a complete sentence with a complete thought. So that phrase that follows is a non-defining clause. And remember, the non-defining clauses use the word which. Here's a second example. This sentence says, the global carbon cycle fuels the processes which are responsible for maintaining the ecological functioning of ecosystems. Now, if we read that sentence without the phrase, it just says, the global carbon cycle fuels the processes. Now, that's not a complete thought because we don't know what processes they're talking about. So it is a defining clause that follows. So it should say, the global carbon cycle fuels the processes that are responsible for maintaining the ecological functioning of ecosystems. 2 more examples coming up for you. We applied a zero-inflated negative binomial regression analysis that is used for count data that exhibit over-dispersion and an excess of zeros. So we shouldn't start the second clause with that because this clause is providing additional information about the binomial regression, but it's not essential information. If the sentence just said we applied a zero-inflated negative binomial regression analysis, that would be a complete sentence with a complete thought. So we're adding additional but non-essential information. Now notice there's a second that in this sentence, and the second one is the correct way to do it. Another example, the way we should not use which is, these markers allowed us to compare genetic diversity of populations which have been suggested to be part of the native distribution region. Why is which incorrect? Well, first of all, there's no comma required in front of that phrase. And then also, if you read the sentence up to that point, it's not a complete thought because you don't know which populations. We need additional essential information about those populations. So these are populations that have been suggested to be part of the native distribution region. The next topic we are going to discuss is how to avoid substituting one part of speech for another part of speech. And this problem is something that I do commonly see in scientific writing. And some examples of this problem are using nouns as adjectives, using nouns as verbs, and using adjectives as nouns. Now this probably doesn't make sense until we talk about some examples. So let's get into some examples here. The first example is not correct because it's using a noun as an adjective. This says, chromatin-bound protein fractions were extracted from mitotic arrested HeLa cells and used for immunoprecipitation. So the phrase mitotic arrested, it's written as if it is an adjective, but it's not a proper adjective. So mitotic is describing cells that are going through mitosis. And just saying arrested HeLa cells is incomplete. So what we need to do here to correct this sentence is say, chromatin-bound protein fractions were extracted from cells arrested in the mitotic cycle and used for immunoprecipitation. The second example we see here is using a noun as an adverb. The sentence that's not correct says, the vectors were purified and were Sanger sequenced to identify the specific cRNA inserts, correct cloning. So Sanger sequenced is not correct because Sanger is not an adverb. Sequenced is a verb and it needs an adverb to modify it. Sanger is not an adverb, it's a noun. So what we need to do is say the vectors were purified and were sequenced using the Sanger method to identify the specific cRNA inserts, correct cloning. So here are a couple of examples where I'm suggesting that you make the writing a little bit longer so that it's correct. Here's another example. This time the sentence is using an adjective as a noun. It says, with respect to who an immature observes, it has been suggested that among socially learning mammals, and specifically among primates, individuals go through three main phases of social learning. Immature is an adjective. It's describing the state of being of some noun. It's not a noun by itself, so it shouldn't be used as a noun. The same with individuals. Individual is an adjective describing some noun. So we have an individual pipetter, we have an individual plant, an individual animal, but we don't have individuals. I know you'll hear it used that way a lot, but it's not the correct way to use the word. What we should do is say, with respect to who an immature primate observes, it has been suggested that among socially learning mammals, and specifically among primates, individual animals go through three main phases of social learning. So that adjective needs a noun to go with it, and not to use the adjective as a noun by itself. Here's another example where the authors are using a noun as a verb. The sentence says, blasting SSR marker sequences against the reference genome showed that they are spread across 8 of 11 chromosomes. So for any of you that have done any work in molecular biology, you know that a blast search is a common step in a procedure of trying to find out more information about a DNA or an RNA sequence. But BLAST is an acronym, Basic Local Alignment Search Tool. It's a noun. So in the lab, we'll talk to each other and say, I'm going to blast this sequence. But that is jargon, right? That is colloquial lab slang. So we shouldn't use it as a verb. We should say blast search results of SSR marker sequences. The next topic we're going to talk about is making sure that your words are in the correct place in your sentence. So a sentence that is confusing is something like this. According to the following criteria, 2 different sgRNAs were designed. Close location to the mutations, following PAM at the 3' end, and 20 nucleotide length. So when I read that sentence, I'm confused because it says 2 different sgRNAs were designed, and then they have a list of 3. And so eventually I figured out that this list of 3 were the following criteria that they were referring to. It was not the 2 sgRNAs that is in the sentence. So what would make the sentence more clear is if they just switched the order of the phrases and wrote it this way. Two different sgRNAs were designed according to the following criteria: close location to the mutation, following PAM at the 3' end, and 20 nucleotide in length. So instead of criteria being separated from the criteria with an interrupting phrase that has another number, we put the list of criteria right next to the word criteria. Also think about where you put the words in a sentence, because the order of the phrases can determine the emphasis. So, for example, if you have these two sentences, site-specific targeting of nucleases such as zinc finger nucleases, TALENs, and the CRISPR-Cas9 system now allow genome editing in a wide variety of cultured cells as well as whole organisms. So in that sentence, the emphasis is on site-specific targeting of nucleases. And the sentences that follow that should probably refer to site-specific targeting of nucleases. Now, however, if you write the same sentence in a different order and it says genome editing is now possible in a wide variety of cultured cells and whole organisms based on site-specific targeting of nucleases such as zinc finger nucleases, TALENs, and CRISPR-Cas9 system, then the emphasis is on genome editing is now possible. So which one do you want the readers to take away as the key message? Do you want them to think that the key message is site-specific targeting of nucleases, which is talking about specific technology? Or do you want the readers to take away that genome editing is now possible, which is more of a big picture point of view in which you go and detail the reasons why genome editing is now possible? So I'm not saying either one of these is more correct than the other one. It really depends on the context. The point is to think about how you structure your sentence to emphasize which is more important. And this is something that we talked about in the previous lesson when we talked about the power positions within sentences. Also, when you are editing, it's really important to go back and edit with an eye for detail, because you're going to find sometimes that as you're typing and revising, you'll accidentally have an extra word included in the sentence, or maybe you accidentally deleted a word that is supposed to be there. And I've been in that situation before where I was missing a word in a sentence and it completely changed the meaning of the entire paragraph. And I sent that manuscript to my co-authors and it caused a lot of confusion because that one word was missing. And when I got back the comments, they'd spent a long time making a lot of comments and explaining them, when in reality none of that was necessary because I was just simply missing a word in my sentence. So watch out for those. Here are some examples of extra or missing words. The sampling design allowed us to construct of a source population from which samples were randomly taken. So the word of is extra there. So it should say construct a source population, not construct of a source population. The second sentence originally said monthly sampling was undertaken, collected during early hours of the day in triplicate in acid wash dried polyethylene bottles. So there's two words there, undertaken and collected. And I think one of them is extra. So you should say monthly sampling was undertaken during the early hours, or monthly samples were collected during early hours. This is probably just a situation where the authors were editing this sentence and they accidentally left an extra word in it. Now, earlier we talked about how you don't need an article for evidence because it's an uncountable noun. You don't have an evidence or plural evidences. You don't have evidences. You have a body of evidence. You can have a piece of evidence, but you can't have multiple evidences. And that's because it's an uncountable noun. When you have countable or uncountable nouns, then you need to use the word less or the word fewer. So you're going to use the word less when you have nouns that can be measured but not counted, or they're uncountable, such as water. You can have 2 liters of water, but you can't have 2 waters. So water should say less. So you have either less water or you have more water because it's an uncountable noun. Now, if you have something that's countable, like containers of water, then you would have fewer containers of water or more containers of water. So with countable and uncountable nouns, you're going to use either the word less or the word fewer. You use the word less with nouns that can be measured but not counted, or they are uncountable. And you use the word fewer with countable nouns. Let's look at some examples of when to use less and when to use fewer. So a not correct sentence would be, the cell-seq protocol has been reported to have a capture efficiency of 3% or fewer. Because 3% is a measurement, it's not a count. So it should be 3% or less. The next example, with more domiciles, one expects more individuals foraging in the area, more flowers tripped, and less floral resources available for bees coming in from surrounding fields. So less resources is not correct, because what they mean by floral resources are the number of flowers. So you can count flowers. So less is not the correct word for floral resources. You would say fewer floral resources. Now, continuing with the idea of countable and uncountable, here's a sentence that is not correct. When we say emerging evidences have revealed, what we should say is emerging lines of evidence have revealed. And another less than fewer example, since less than 10 individual plants were observed. Now, what you need to think is, are individual plants countable? Yes, they are. So instead of saying less, you should say, since fewer than 10 individual plants were observed. Here we see another example. This sentence says, since chronic injuries were described as a continuum of clinical pathologies more than 20 years ago, much advances have been achieved. So much advances doesn't really work. There are a couple of different ways that I could see revising this sentence depending on what the authors were thinking. So they might be thinking that advances are individual things, like electricity is an advance, the telephone is an advance, the laptop computer is an advance. So those are three different advances. So they could be referring to specific technologies. Or they could be referring to advances as a whole. So like saying that the field of medicine has greatly advanced since the 1860s. So depending on the meaning in the author's mind, they could revise this sentence in one of two ways. The first way would be, since chronic injuries were described as a continuum of clinical pathologies more than 20 years ago, many advances have been achieved. So that would be the technology meaning. Or they could say, since chronic injuries were described as a continuum of clinical pathologies more than 20 years ago, the field has much advanced. Or you could say the field has advanced greatly. Either way would be fine. Now let's start the part of the lesson where we look at punctuation. Punctuation is kind of difficult in the English language. It's easy to make mistakes in punctuation. There's no way I can cover everything, and I can't teach you all of the rules of punctuation. So what I can do instead is show you some examples of common punctuation errors and how those punctuation errors can be repaired. So one of the common mistakes that we see with punctuation in scientific writing would be missing commas. So here's a sentence that says, the mechanism can be exploited to facilitate, for example, gene tagging or introduction of point mutations at endogenous loci by co-delivery of a repair template that harbors this specific feature. There are no commas in that sentence. So we use a comma before certain words like which or thus, or we use them after certain words like however or therefore, or we can use them when we want the reader to pause within the sentence. I would revise this sentence as such. The mechanism can be exploited to facilitate, for example, gene tagging or introduction of point mutations at endogenous loci by co-delivery of a repair template. So I've set apart the phrase, for example, with commas, so a comma before and a comma after. And then I've also set apart the example phrase with commas, gene tagging or introduction of point mutations at endogenous loci. So having those commas is going to help your reader read this sentence and make it grammatically correct. Now sometimes authors will put in unnecessary commas, commas that are not needed. So an example would be like this. The high costs of feeding for predator species are determined mainly by the difficulties of finding, handling, attacking, and ingesting the prey. So those first 4 commas are not necessary. They shouldn't be there. They make the reader pause, but the pauses don't really have any purpose. I would just eliminate those first 4 commas. The ones in the list are necessary, and so we'll leave those as they are. Here's an example of a sentence that has both extra commas and missing commas. So honeybees, Apis mellifera, comma, are critical for agricultural ecosystems, but are exposed to many biotic stressors, including bacteria, viruses, and fungi. And I read that as if the commas were there. They should be, but they're not. So the first comma is not necessary. Just say honeybees are critical for agricultural ecosystems. There's no reason to pause and say honeybees are critical for agricultural ecosystems. That's not how we should do it. But there are 2 missing commas later in the sentence. Before you get to the examples where the phrase says, including bacteria, viruses, and fungi, you need a comma before you get to that example phrase. And we also need a comma before the and in the last item of a list. This is called the Oxford comma. In this case, the Oxford comma is after viruses in the phrase that says, including bacteria, viruses, and fungi. If you don't include that Oxford comma, then viruses and fungi looks like it's one term. So it would say including bacteria, viruses, and fungi. That just doesn't work very well. So I highly recommend using this Oxford comma. Now I'd like to illustrate the importance of commas with an example that's not a scientific writing example. It's kind of a fun example, and I saw this somewhere. So here is how misplaced or missing commas can change the entire meaning of a sentence. We have the phrase, I like cooking my friends and my pets. That means whoever is saying the sentence likes to cook their friends and they like to cook their pets. And that is, highly illegal and unethical and repulsive. Now, if you have 1 comma, it says, I like cooking my friends and my pets. That means that the speaker is addressing their friends and their pets. Now, if you have the 2nd comma, I like cooking my friends and my pets. Now it means it's a list. The person likes to cook, the person likes their friends, and the person likes their pets. So the 3rd version is the correct version of the sentence, and you can see how missing 1 or 2 of the commas completely changes the meaning of the sentence. One of the things to keep in mind for using commas is that when you have an adjective clause, it needs to be set apart with the commas when it's modifying the noun that the adjective refers to, but not when it is defining the noun that the adjective refers to. So the correct way to do this would be the samples that were collected at the first time point were analyzed by RT-PCR, while the samples that were collected at the later time point were analyzed by RNA-seq. That is correct because we have 2 that phrases. That phrases are defining, as we learned earlier when we talked about that versus which. With these defining phrases, we don't use the commas. It would be incorrect to write it this way. The samples, comma, that were collected at the first time point, comma, were analyzed by RT-PCR, while the samples, comma, that were collected at the later time point, comma, were analyzed by RNA-seq. Again, because these adjective clauses are defining, they're not modifying. Another common comma error that you'll find frequently in scientific writing is called the comma splice. And this is when 2 sentences are connected by a comma instead of being separated by a period. A comma splice is usually used when the author wants the reader to quickly read the next sentence. So here's an example of the comma splice. We selected 48 mice at random, comma. They were assigned to 4 treatments. It should say, we selected 48 mice at random, period. They were assigned to 4 treatments, because it's 2 separate sentences. So don't join them with a comma. That's a comma splice. Another example is this. HO and HS are geographically close, approximately 20 kilometers, and have similar genetic structures, comma, they should be grouped as a single management unit. All right, so that comma splice needs to be corrected, but how should we correct it? There's two different ways that I can see. The first one is to say, since HO and HS are geographically close, approximately 20 kilometers, and have similar genetic structures, comma, they should be grouped as a single management unit. We still have the comma there, but because we've added the word since to the beginning of this sentence, now it works. The other way we could do it is just make it two separate sentences by adding a period instead of a comma and a transition word, therefore, at the beginning of the second sentence. Now, semicolons are a piece of punctuation that are pretty useful, but they're often used incorrectly in scientific writing. If you're going to use them, make sure you know how to use them correctly. Semicolons should be used before a clause. They shouldn't be used like a splice comma, or shouldn't be used like a comma. So an example of a way to not use the semicolon correctly is in this sentence. We harmonize the probes across the platforms by determining the probe sequences from different annotation files for each platform, semicolon, renumbering the probes on the basis of unique probe sequences. That's not the proper use of the semicolon. We should replace it with a comma and a word that explains the sequence here. We harmonize the probes across the platforms by determining the probe sequences from the different annotation files for each platform, then renumbering the probes on the basis of unique probe sequences. Now, we're at the last topic for this lesson, and I want to talk about spelling and grammar. I think it goes without saying that you need to use correct spelling and correct grammar in scientific writing. So why am I even bringing this up? I'm bringing this up because it is so important that when you're editing, you need to really be careful and be detail-oriented to make sure that you're not making spelling mistakes and grammar mistakes. So make sure you use a spell checker when you write your document. The problem with the spell checker is there are a lot of scientific words that are not in the spell checker, and it will pick them up as spelling errors. And so it's kind of annoying to use a spell checker because so many words come up and you have to sort through those, but it will find your spelling errors. One thing you can do is add all your scientific terms to the spell checker's glossary so that it doesn't bring those up as misspellings. You can also consider using a grammar checker. So there are free grammar checkers out there on the internet that you can download, or Microsoft Word has a built-in grammar checker that catches a lot of grammatical errors. They're not perfect, and you still have to make some judgment calls. Sometimes the grammar checkers will flag things as grammatical errors, but you don't want to change it because it's going to change the meaning. So it's not necessarily an error, even if it comes up as one. So you can't just blindly accept all the results of the grammar checker, but do consider using one. And also try to have an outside reader. So your co-authors should be catching any of these grammar or spelling mistakes, but they might not. So you might also consider getting someone else to read your work, a friend or a colleague from a slightly different field that's not going to be focused on the science, and they can pay attention to the writing. Now, I'd like to show you an example that I came across a few years ago when I was writing a paper, and I was reading a related paper to use in the introduction or the discussion of my paper. And I came across this sentence. It says, for the population, Fro2, a proton with reductase activity interacts with cytochrome P450-like proteins. So because this is my field, I recognize that this sentence had a lot of errors in it. Even if it's not your field, you can recognize some of these errors. The first phrase, for the population, what population are they talking about? And what do they mean, for the population? And then it says Fro2 is a proton with reductase activity. If you know what a proton is, it doesn't make sense that a proton has reductase activity. And what kind of reductase activity? There are thousands of kinds of reductase activities. And what does it mean it interacts with cytochrome P450 like proteins? It interacts with cytochrome P450 like proteins interact with cytochrome P450 is the way that reads, but that doesn't really make sense either. And so what I would do with this sentence if I had the opportunity to correct it is I would say mapped in the X population was Pro2, a protein, not a proton, a protein that has ferric chelate reductase activity and that interacts with cytochrome P450-like proteins. So it needs to have that dash there, P450-like. And that's a completely different meaning than without the dash. Well, that brings us to the conclusion of this lesson. I'd like to reiterate the learning outcomes as we wrap it up. And so after this lesson, you will be able to recognize common errors in sentences. You'll be able to explain why they are errors, and you'll be able to correct these common errors. As you put these lessons into practice and edit your own writing and practice on other writing that you find in the literature, I hope you enjoy the process. And as you continue writing your manuscripts and grant proposals, happy writing. Hello, scientific writers. Welcome to the next lesson. This lesson is on keeping your reader engaged by writing with clarity. So in this lesson, we're going to talk about quite a few common problems that are confusing for readers, and they make it harder for readers to understand what you're saying, and that makes extra work for the reader. And if you know my philosophy of scientific writing, the number one rule is to make it easy for your readers. So we don't want to confuse them and cause them to have extra work in thinking about what you're writing, trying to understand what it is that you are saying to them. Let's start by looking at the learning objectives or the learning outcomes for this lesson. Because it's a long list of different topics, I'm going to keep the learning objectives pretty simple. After this lesson, you'll be able to recognize common errors in sentences, you'll be able to explain why they are errors, and you'll be able to correct those common errors. Today we have 11 different common errors that we're going to talk about. So let's take a look at the list, which is our overview of this lesson. Problems that confuse readers and reduce clarity include noun clusters, jargon, starting a sentence in the middle of the idea, pomposity or overly fancy language, misplaced modifiers, faulty predication, faulty coordination, separating the subject and the verb, having the verb at the end of the sentence, using respectively in your sentence construction, and problems with tenses. So I think you're going to enjoy this lesson. I know this is the kind of stuff that I really enjoy editing, finding these kinds of problems and repairing the sentences, making them read more clearly. I just love doing this stuff. So I hope you enjoy this lesson. Let's get started. So we'll start with our first topic, noun clusters. What are noun clusters? Noun clusters are also called noun trains or noun strings by different writing experts. You have a noun cluster when there are 4 or more nouns in a row in your sentence. So they're either nouns or words that are usually used as nouns. They might be used as adjectives sometimes in these noun clusters. Nonetheless, they're normally used as nouns. And what happens when a reader gets to a noun cluster in a sentence or a paragraph is that they really have to stop and think. It takes a lot of cognitive effort to sort through a noun cluster. You'll see why here in a second when I show you some examples. So here's our first example. This example is actually from a title of a paper. Improved apple latent spherical virus-induced gene silencing in multiple soybean genotypes through direct inoculation of agro-infiltrated Nicotiana benthamiana extract. So, do you see where the noun cluster is? It's right there at the beginning. Improved apple latent spherical virus-induced gene silencing. So when you get to this phrase, you really have to unpack it. It's a complicated series of nouns to work your way through. What I would suggest revising this title to is as follows. Improved gene silencing in soybean using apple latent spherical virus by direct inoculation of plant extract. I have broken up this noun cluster, and I have also simplified the title a little bit. I took out some of the methodological references. Agro-infiltrated Nicotiana benthemana, I don't think that's really necessary in the title. We'll just call it plant extract. Now instead of saying improved apple latent spherical virus-induced gene silencing, we have improved gene silencing. And then I've described that gene silencing with some prepositional phrases in soybean using apple latent spherical virus by direct inoculation of plant extract. I recognize that we still have apple latent spherical virus, which is 4 nouns in a row. But that's the name of this virus. So there's really no way to break that up without making it become incorrect, because the name of the virus is apple latent spherical virus. So we have to live with that noun cluster, but we broke up the bigger one. Here's another noun cluster. Again, this is from a title. Bond behavior of iron-based shape memory alloy reinforcing bars embedded in concrete. It has good information in the sentence, but is really hard to read and sort through. If I were to suggest a revision to these authors, what I would say is this one. Bond behavior of iron-based reinforcing bars made with shape memory alloy when embedded in concrete. So we've broken up the noun cluster into some prepositional phrases to explain the parts of that cluster a little bit better. The next item on our list is to avoid too much jargon. So I don't say never use any jargon, but I'm saying avoid too much jargon. So what is jargon? Jargon is defined by the Merriam-Webster dictionary, as you see here. Definition number 1, the technical terminology or characteristic idiom of a special activity or group. Number 2, obscure and often pretentious language marked by circumlocutions and long words. And number 3 is confused, unintelligible language. So I think all 3 of those definitions apply to what I'm talking about when I say jargon. Now, in my opinion, we have to use technical terminology. We can't avoid talking in technical terms when we're talking to other scientists in our field. We need to use the correct terminology. But the second part of that definition says characteristic idiom of a special activity or group. That's the part that I'm focused on, is the characteristic idiom of the special group. So we want to avoid using terms that are not specifically technical terms, but that are terms that this group knows that exclude other people that don't know these terms. And when the readers find the language unintelligible, what do? They stop reading. And if they stop reading, they're probably not going to cite what you have written, and they're probably not going to review it very favorably, and that's going to hurt your chances of getting published or getting your grant funded. Let's take a little bit deeper dive into jargon. I really like this quote from Martinez and Mamola in an article published in 2021. Jargon illustrates complex concepts only in the minds of those sharing a common background, while precluding everyone else from understanding. A reader might not understand the jargon at all, get the message only partially, or, after an extra mental effort, figure out its meaning. Now, on the right side of this slide, you can see a figure from this article, and they show 2 different panels. The top one is comparing the proportion of jargon in the title to the citation rate. And the bottom one is comparing the proportion of jargon in the abstract to the citation rate. As you have a lower proportion of jargon in the title or in the abstract, you have a higher citation rate. In other words, as the jargon proportion increases, we see the citations start to fall off. The take-home message here is reduce the amount of specialized terminology as much as possible and avoid using too much jargon in your writing. So here's an example of using jargon in the case that it is a correct technical term, but it's a technical term that hardly any people are going to know, and it's really not relevant to the rest of this paper. So we could use more simple language. In this case, it is also greatly appreciated and commercialized for its organoleptic properties. Now I had to look up organoleptic. I've never heard that word before, so it immediately excluded me, even though I'm a PhD level scientist. And once I looked it up, I found out what it meant, the properties of flavor and texture. So why shouldn't we just say that? And instead of saying greatly appreciated and commercialized, let's try to simplify those words. My revision is suggested here. It is also valued by consumers for its flavor and texture. Now, I think that has the exact same meaning of the original sentence, but it's written in a jargon-free way. The next problem we're going to talk about is starting the sentence in the middle of an idea. When you start the sentence in the middle of an idea, the reader has to hold that middle part until they read the first part of the idea, and then in their mind change the order of the phrases. So it looks something like this. Based on the analysis of the hyperspectral curve and the mathematical transformation of soil data in the red soil plantation, a negative correlation was observed between spectral reflectance and SOM content. So the important part of that sentence is the last part, a negative correlation between spectral reflectance and SOM content. Yet, that's buried behind this really long first part that you're asking the reader to hold in their mind and remember until after they read the second part. So what I would suggest to these authors is to revise the sentence like this. There was a negative correlation between spectral reflectance and SOM content based on the hyperspectral curve and the transformation of soil data in the red soil plantation. So notice that I've reversed the order of the phrases. First I gave the result and then the reasoning for that result. I also took out the phrase was observed. A negative correlation was observed. That's a little bit excessively worded and it throws in this passive kind of construction referring to an unidentified agent. So who observed this correlation? It doesn't say. So what I'd rather do is just focus on the result. There was a negative correlation. And you can see by looking at it, the sentence is a little bit shorter after the revision. And shorter sentences are more readable. So we want to make them short whenever possible. So a couple things going on there, but in terms of this lesson, the thing I want you to notice is we've moved the main idea of the sentence to the topic position and then explained it with the based on phrase. Here's another example for you. It says, although the chromosome scaffold is first visualized during the initial period of the middle-late prophase and becomes more distinct during the pro-metaphase to metaphase, some scaffold proteins have been found to localize to chromatin prior to the initiation of chromosome condensation or during interphase. I don't know about you, but that for me is a really difficult sentence. If I'm reading that sentence, I have to read it at least twice to understand it, because the entire first half of it is telling me something that I have to remember until after I read the second half, and I can't remember that. So I have to go back and reread the first part of the sentence. Also, I feel like the first part of the sentence has additional information that's not really necessary to get the point across. The point being that some scaffold proteins localize to chromatin prior to chromosome condensation. Here's how I would suggest revising this sentence. Some scaffold proteins localize to chromatin before chromosome condensation or during interphase, even though the chromosome scaffold is not visible until the initial period of the middle-late prophase. So you'll see what I've done there is I've changed the order of these phrases, and I also removed some of the additional, very detailed information that is probably something that, while it's important, it's not really necessary to understand the point of this sentence. If that's really important to the story, that can be introduced in the following sentence or the previous sentence. But let's look at 3 more examples. I'm not going to show you revisions for these, so I would like you to practice by deciding how you would revise these sentences. All right, let's take a quick look. Although purging can reduce the level of inbreeding depression as well as fitness decline during inbreeding periods, inbreeding depression can nonetheless strongly affect genetic diversity in the long term. Since studies in model organisms have shown that aging is characterized by many alterations at the molecular, cellular, and tissue level, a transcriptome analysis might lend greater insight than a static genetic investigation. Because assay annotations using BAT correspond to Bayo class IDs, it is possible to leverage the ontology for querying and analysis of annotated essays, including interference by reasoning. Most of these times that the author is beginning the sentence in the middle of an idea, it starts with something like although, since, because, or those kinds of meta-discourse phrases. So I'm not saying that you should always avoid using that kind of construction, but if you do start a sentence with those phrases, think very carefully about whether the meaning is clear or if you're starting in the middle of an idea. The next topic we are going to discuss is how to avoid pomposity or overly fancy language, including language that's not necessarily fancy, but it's overly complicated. And I think this following quote by Steven Pinker shows the importance of this common problem. He says, "The methods section of an experimental paper explains, participants read assertions whose veracity was either affirmed or denied by the subsequent presentation of an assessment word. After some detective work, I determined that it meant participants read sentences, each followed by the word true or false." Now, that second version is much more clear. Assertions is very abstract. It's an abstract noun, but sentences is very concrete. So participants read assertions or participants read sentences. Also, it's veracity. Okay, so veracity is a kind of a pompous word. It's overly fancy. It's not necessary, and not very many people use that word. And affirmed or denied, why not just say true or false? And the subsequent presentation of an assessment word. So subsequent presentation, assessment, these are all multisyllable words. They decrease readability. And subsequent means something followed. Why not just say followed? That's a common word everyone knows. So let's take a look at a scientific writing example. The CRISPR-Cas system, which has entered the mainstream in recent years and been widely used in humans, animals, microorganisms, and plants, possesses the outstanding advantages of high simplicity and efficiency in contrast to other techniques. All right, so a lot going on there. It's kind of a complicated sentence. It has a lot of phrases. And some of those phrases I feel like are not necessary for the meaning of the sentence. For example, CRISPR-Cas has entered the mainstream in recent years. What does it really mean by mainstream? Does that mean you can go to Target or Walmart or Amazon and buy CRISPR-Cas9 system? No, of course not. It's not mainstream. It's still in the scientific realm in very specialized laboratories. So I don't think that phrase really means anything. But then when we look later in the sentence, after this phrase where it tells where it's been widely used, we get to the phrase that says, possesses the outstanding advantages of high simplicity and efficiency in contrast to other techniques. So here we're getting into some complicated words with a lot of syllables. Possesses, and we have this outstanding as an adjective for advantages. And then we have some abstract nouns like simplicity and efficiency with an adjective high. In most of scientific writing, I really recommend that you avoid adjectives as much as possible and avoid adverbs as much as possible. I'm not saying that you should never use them, just don't use them unless it's absolutely necessary. And so outstanding advantages, this is not really necessary. This is one of those signifiers of mood. So this is the author's opinion that the advantages are outstanding. Let's leave that out. And let's change simplicity and efficiency to simple and efficient. So here's my suggested revision. The CRISPR-Cas9 system, which has been widely used in humans, animals, microorganisms, and plants, is simple and efficient in contrast to other techniques. So I think we've got all the important information retained in that revision. It's quite a bit shorter, and that by itself makes it more readable, but we've also eliminated some of the polysyllable words that also decrease readability. Now, I recognize that in my revision, I still have something that we're talking about in this lesson, which is a phrase that is between the subject and the verb. But, sometimes it's okay to do it if it's a simple phrase that helps to define the subject. Here's another example we can look at for simplifying the language. Adaptation to fluctuations in available nitrate involves multifaceted responses in distinct developmental programs controlling root system architecture, shoot morphology, seed germination, stomatal closure, and flowering time. So I feel like the end of that sentence is fine. I would not recommend changing it. But I think the beginning of it is a little bit overly fancy and overly complicated. We have seen this sentence or part of this sentence in earlier lessons when we were converting abstract nouns to concrete nouns. But I think it illustrates this point also. So what I would recommend doing is changing it to something like this. Plants adapt to fluctuating available nitrate with multiple responses that control root system architecture, etc. So I haven't changed the last part of that sentence. But what I've done is I've added an agent. Plants adapt. So we change adaptation to adapt. We change fluctuations to fluctuating. And the sentence is now less fancy and more direct. I also took out this developmental programs controlling. So really what the authors seem to be getting at is that there are changes in root system architecture, shoot morphology, etc. The next topic we're going to cover is how to avoid unclear modifiers. These include misplaced modifiers, dangling modifiers, and squinting modifiers. Now don't worry, I'm not going to expect you to learn these terms. They're kind of difficult concepts, for me anyway. I think it's easy to understand that when modifiers are not modifying what the authors intend for them to modify. So I'll show you some examples of that, and I'm not really going to name them as misplaced, dangling, or squinting. That doesn't matter. The thing that matters is being able to recognize a misplaced modifier and know how to correct it. So here's our first example. Baculovirus is a well-established vector for gene delivery into a wide range of human cells with minimal cytotoxicity. So the problem here is the phrase with minimal cytotoxicity. It's modifying something in this sentence, but it's really not clear if it's modifying the well-established vector or if it's modifying human cells. So are they saying human cells with minimal cytotoxicity, or are they saying that the vector has minimal cytotoxicity? That's an unclear modifier. A second example is this one. The protein composition of venom from honeybees was examined here, employing an untargeted proteomics approach to characterize the proteins. Who or what employed the untargeted proteomics approach? There's nothing in the sentence before that employing would refer to. Here's an example that I'm going to show you a revision. The CL peptide receptor pathway modulates a homeodomain master regulator transcription factor in the apical meristem with poorly defined signaling mechanisms. So what this sentence implies, the way that it's written now, is that you have apical meristems with poorly defined signaling mechanisms, and you have apical meristems with well-defined signaling mechanisms. And that the CL peptide receptor only works in those meristems that have poorly defined mechanisms. Now, of course, that's not what they meant. That doesn't make sense biologically, but that's the way the sentence is written. So how would you correct that? One way would be like this. The CL peptide receptor pathway modulates a homeodomain master regulator transcription factor in the apical meristem. However, the pathway's signaling mechanisms are poorly defined. Okay, so now we know what this modifying phrase is modifying. It's modifying the pathway, not the apical meristem. Another example is environmental stress elicits rapid and profound responses in plants designed for protection, avoidance, or progeny survival through changes in conditions. The way this is written, it sounds like the plants are designed for protection, avoidance, or progeny survival. but I don't think that's what the authors meant. I think they're talking about the responses are designed for protection, avoidance, or survival. So what I would suggest to these authors is to break it into two sentences. That's going to be the easiest way to solve this problem. Environmental stress elicits rapid and profound responses in plants. These responses are designed for protection, avoidance, or progeny survival. An additional example is recombinant cells expressing the monoclonal antibody were cultured in tightly controlled bioreactors for 12 hours prior to the addition of ammonia to stress the cultures. So here, to stress the cultures, is that referring to the ammonia, or is it referring to culturing the cells in bioreactors for 12 hours? So is culturing the cells in bioreactors for 12 hours stressing the cultures, or is the ammonia stressing the cultures? It's not entirely clear the way this sentence is currently written, so what we could do is revise it as such. Recombinant cells expressing the monoclonal antibody were cultured in tightly controlled bioreactors for 12 hours. Then ammonia was added to stress the cultures. So it's a subtle change, but it does clarify what that modifier is referring to. The next topic to discuss is to avoid faulty predication. Faulty predication is when a sentence is written such that it attributes an action to something that cannot do that action. So remember what a predicate is. A sentence has a subject and a predicate, and the predicate includes the verb and the rest of the sentence. So the subject is doing something based on the verb if it's an active verb, or the subject is being something if it's a state of being verb. So that doing or being is the predication of the subject. So we want to make sure that when we say the subject is doing something or being something, that it can actually do or be that thing or action. So how does this look in a sentence? Here are two examples, and then I'll show you revisions for these examples. The variation of peptide profile considered multiple ecological factors. So this is telling us that the variation considered these factors, or that the profile considered these factors. Variation is not capable of considering anything, and a profile is not capable of considering anything. Now, the people that collected the information about the variation, or the people that built the profile, could consider ecological factors, but the profile itself or the variation cannot do that. Secondly, this study aims to characterize the nectar released by flowers during the flowering season. And this is one that you see a lot. The study aims to do something. Well, the study cannot aim to do something. It is the investigators who aim to do them. So we need to be careful about the wording there and not predicate the intention onto the study. So how do we revise these sentences? Let's introduce an agent. We considered multiple ecological factors for constructing the profile of peptide variation. For the second one, in this study, we aim to characterize the nectar released by flowers during the flowering season. Another example is this one. Phylogenetic analysis demonstrated that DUF336 domains are encoded in all three domains of life. So what's the problem here? It's saying that the phylogenetic analysis demonstrated something. Well, analysis can't demonstrate something. The people doing the analysis can use the results of the analysis to demonstrate that thing, but the analysis cannot demonstrate it. So we should rephrase it to something like this. We demonstrated that DUF336 domains are encoded in all three domains of life by analyzing their phylogenetics. Also notice that I've changed analysis to analyzed. So I've changed an abstract noun to an active verb. So now the people analyzed, and that allowed the demonstration. All right, the next one is we're going to look at avoiding faulty coordination. What is that? Faulty coordination is when the second phrase or clause of a sentence does not logically follow the first phrase or clause of that sentence. Here are two examples of a faulty coordination. Although the gene copy numbers of strain A and strain B have been quantified in the river, these two clades cannot represent the entire community of unicellular diazotrophs. Those two parts of the sentence don't logically connect. There's no reason to think that quantifying gene copy numbers means that they cannot represent the entire community. Even if they do represent the entire community, you could still analyze gene copy numbers. So those two phrases don't really logically connect. All right, a second example is almost 70% of all global deaths are due to non-communicable diseases, A third of those were individuals aged 69 years or older. There's no reason to think that individuals 69 years of age or older are the only ones that can catch non-communicable diseases. That's not really a logical link. Those are two different facts that these authors are trying to establish, but they're not logically connected to each other. My suggestions would be to revise these two sentences as we see here. These strain A and strain B clades have been identified in the river, suggesting that they are a part of the community of unicellular diazotrophs. So the first thing I did was I removed the gene copy numbers of strain A and strain B. It seems to me that the presence of strain A or strain B is more important than their gene copy numbers. That's what the sentence is about, the presence or absence of different organisms in these communities. So the gene copy numbers don't really have anything to do with that. But even if we took that out, the original sentence is saying that although we found strain A and B in the river, they cannot represent the entire community. Well, why not? I mean, that logically doesn't work. And the thing that's throwing me is the word although. Although they were found in the river, they cannot possibly be all of the community. Well, that's probably true, but the although part makes it something that there are steps left out. So I took away the although and I changed the emphasis to reflect what I believe the authors mean, which is we've identified these strains in the river, but there are probably additional things living there. That's what my revision is getting at. So instead of using this negative language, they cannot represent the entire community, I changed it into a different orientation, suggesting that they're part of a bigger community. For the second revision, I just separated it into two different sentences because there's no way to logically connect those two ideas in the same sentence. Here's another example of this faulty coordination. Our assay differentiates between vaccinated and non-vaccinated individuals by measuring antibodies against the N protein, semicolon. The current vaccines and several in the pipeline are all based on the S protein. Okay, well, there's really no logical connection between this assay uses the N protein and other assays use the S protein. What the authors are trying to do there is set up a contrast and comparison, but they've written it such that it's a logical relationship. So what I would suggest them to do is revise it this way. Our assay differentiates between vaccinated and non-vaccinated individuals by measuring antibodies against the N protein. In contrast, the current vaccines and several in the pipeline are all based on the S protein. So the same information, but it's a little bit more clear what the relationship between those different clauses is intended to be. Okay, so the next topic or the next common problem that we're going to discuss is keeping the subject and the verb close together. Now, a lot of times what we'll see is that there are phrases that interrupt the reader's attention with additional information. And I had an earlier example in one of our other topics that I left an interrupting phrase in the revision. Here are two examples on this slide, and I'll show you the example and the revision immediately together. The first one says, however, 4 other experiments found, regardless of whether hosts formed determinate or independent nodules, no such evidence. So that phrase in blue is interrupting. So technically, this is not an interruption between the subject and the verb, but the phrase does interrupt the sentence and leaves the readers in suspense. So that's really the point of this problem. So if we revise this sentence, however, 4 other experiments found no such evidence, regardless of whether hosts form determinate or independent nodules. That's more clear because we know what the experiments found, and then we have additional information, instead of throwing that additional information in the middle of the sentence. The second example is several strains of UCYNB, including the widely distributed strain WH8501, have been isolated and relatively well studied. So that phrase in red interrupts between the subject, which is several strains of UCNYB, and the verb, which is have been isolated. So in the revision, we simply move that phrase to the end, just like we did in the first one. Another example is here, messenger RNA, mRNA, which is an important intermediate molecule that transports genetic codes from DNA to ribosomes for protein expression, has been suggested as a promising tool in novel therapeutic approaches for the treatment of several diseases and cancers. So this is all very good information. It's all very important. What we have here is a phrase that's defining what messenger RNA is, that's interrupting between the subject, which is messenger RNA, and the verb, which is has been suggested. And so what I would do here is break this into two sentences. Messenger RNA is an intermediate molecule that transports genetic codes from DNA to ribosomes for protein expression, period. Next sentence, it has been suggested as a promising tool, etc. So that makes two shorter sentences compared to the original one long sentence that had this interrupting phrase. And now it's easier to understand and more clear. The next topic is to be careful about where you put the verb. So just like separating the verb and the subject with these long interrupting phrases, it's also easier to read a verb if it's earlier in the sentence than if it's at the very end of the sentence. And when the verb of the sentence is the very last word, it has an awkward rhythm, and it makes it feel like the sentence just suddenly ended. It gives it a very abrupt ending that feels strange to the reader, and whenever I encounter such a sentence, I have to go back and reread it a second time because I'm expecting something to come after the verb. Let me show you some examples of putting the verb at the end of the sentence. However, discrepancies in the interdependency of chromosome localization among these previous studies existed. Furthermore, interactions between KIF4 and condensin 1 in the cytoplasmic fraction were investigated. Species that are more adaptable to changing environments through phenotypic plasticity and selection of adaptable traits survive. So I would revise all of these sentences if I had the opportunity, and this is how I would do the revisions. For the first one, however, there are discrepancies in the interdependency of chromosome localization among these previous studies. Okay, so I've changed the verb exists to there are. They're both state of being verbs, but I just feel like saying something exists, it just has an awkward feeling to me, so I prefer to say there are. For the second sentence, I revised it to say, furthermore, we investigated interactions between KIF4 and condensin 1. So I've given an agent to this sentence, and I've made it an active verb. For the third sentence, I moved survive much earlier. Species that survive are more adaptable to changing environments. So when you have that verb earlier in the sentence, it's easier for the readers to understand what it is you're trying to tell them. The next common problem that I would like to address is using respectively as a technique when you have a list of items that you're trying to tell some details about. And the reason this is a problem is because when you provide multiple values with respectively, usually the reader has to go back and read that list a second time to match up the value with the noun that it goes with. So this requires extra effort on the part of your reader. And it doesn't usually make the sentence any shorter to use respectively. I think that's the reason a lot of authors do it, is they feel like it makes the sentence shorter. But if you do the revisions, it's actually not making them shorter, or if it is, it's only by 1 or 2 words. So let's look at some examples of what I'm talking about with respectively and how the revisions look compared to the original. Example 1. In New York City, there were slightly slower rates of rise of 1.2 plus or minus 0.1 millimeter per year, and the slowest rates of rise occurred in Connecticut and North Carolina, with 1.0 plus or minus 0.1 and 1.1 plus or minus 0.1 millimeters per year, respectively. So when I read that, I see the two states and then I see the two values, but to put them together, I have to read it again. I have to go back and say, okay, so 1.0 goes with Connecticut and 1.1 goes with North Carolina. So it takes at least two readings of the sentence to put this together. The second example is CXCL10 levels were significantly elevated in both severe and mild to moderate COVID-19 cases compared to healthy controls, p less than 0.01 and p less than 0.05 respectively. And so I have to go back and say, okay, p 0.01 goes with severe and p less than 0.05 goes with mild and moderate. If we revise it without respectively, what we're going to do is put that information directly with the term that it goes with. And so it will look something like this. In New York City, there were slightly slower rates of rise of 1.2 plus or minus 0.1 millimeter per year, and the slowest rates of rise occurred in Connecticut with 1.0 plus or minus 0.1, and North Carolina with 1.1 plus or minus 0.1 millimeters per year. And you can see by looking at the sentences that it's not longer. In the second example, we'll now put the p-values directly after the severe and directly after mild moderate COVID-19 cases. And you can see that looking at the text, again, it's not longer to take away respectively. One more example for you. Importantly, treatment of male mice bearing tumor xenografts with daily subcutaneous injections at 10 milligrams per kilogram for 3 days resulted in 37% and 76% downregulation of BRD4 and c-MYC levels, respectively, in tumor tissue. So let's just say this. Importantly, treatment of male mice bearing tumor xenografts with daily subcutaneous injections at 10 milligrams per kilogram for 3 days resulted in 37% downregulation of BRD4 and 76% downregulation of c-MYC levels in tumor tissue. So the length is exactly the same, but it's much easier to read. You don't have to read it twice to match up the numbers with the genes. Next, let's talk about looking for problems with tenses. Now, I know tenses are something in the English language that are difficult for a lot of people. So it might take you some practice to get used to using tenses, and that's okay. But as you're going through your editing process, this is one of the things I want you to have on your checklist to look for, is to make sure that the tenses match up with the verbs and the nouns and the articles. So let's look at a couple of examples where the tenses are not quite right. The first one says, for example, Imbalbasania is known to be introduced from China to the Ryukyu Isles in Japan already in the 16th century. Okay, so we're talking about something that happened in the past, in the 16th century, but the verbs and other words used are in the present tense. So there's a mismatch there. The second example says, recent studies are pointing toward the potential role of chromatin modifications in epigenetics in plant responses to environmental changes. So this is a form of present tense, but it's got some implications that are different than the simple present tense. And so I'm going to explain that when I look at the revisions. So let's look at revisions for the first example. It should be revised to say this. Imbalbasania is known to have been introduced from China to Japan by the 16th century. Now we're talking about it in the past tense. For the second example, it's better to use the simple present tense. Recent studies point toward the potential role of chromatin modifications, rather than recent studies are pointing toward the potential role. Now, what is the difference here? So when we're using this verb, the studies are pointing towards chromatin, it implies that that's happening at this very moment and that it could stop happening in the future. All right, here's another example, and this one has a couple of different tense issues going on. So let's read the example first. the sentence says, it is previously shown that KIF4 involves in cytokinesis by functioning at midzone during cell division. So the first verb is the one that's referring to the past. That should be a past tense verb. It was previously shown. And then the second part of the sentence is the fact of nature that continues to the present. KIF4 is involved. So they've just chosen the wrong form of involve. We can't use involves in the way that it was in the original sentence. It should say is involved in. So even though involved sounds like a past tense verb, the way it's being used with the present tense is shows you that it's something that is true at the current time. So the tenses can be a little bit complicated and hard to explain, but make sure if you have any questions on those that you get some outside opinions or use your grammar checker to help you decide which is the right way to go. All right, so we are wrapping up this lesson. Let's look back at the learning outcomes. So after this lesson, you will be able to recognize common errors in sentences, explain why they are errors, and you'll know how to correct these common errors. So as you put these ideas into practice on your own writing and on other people's writing, I hope you enjoy the process and happy writing. Hello, scientific writers. Welcome to the next lesson. This lesson is on being concise. The title of the lesson is Keep Your Reader Awake and Alert with Concise Writing. So, awake and alert, what am I talking about here? Well, if your writing is too long, the reader is going to get bogged down. What is concise? Concise is as short as it can possibly be while not losing any meaning or content. If your writing is longer than it needs to be, that's extra work for the reader, and they're going to get tired. They're not going to be alert. And eventually you might put them to sleep. Being too long, not concise, takes away from clarity, takes away from readability and comprehension and all of these things that we've been working on in this course. So we want our writing to be concise. Readers prefer concise, so give the readers what they want and what they need to read your work so it can have impact. Let's begin by looking at the learning objectives for this lesson. After this lesson, you'll be able to recognize common writing problems that add length. You'll be able to edit those common problems to achieve conciseness, and you'll also be able to omit text that does not need to be included. So here's our list of things that we're going to focus on in this lesson. It's a list of 10 items. And I'll have some examples for you for most of these items, although not for every single one of them. The first thing we'll focus on is how to keep sentences short and with one idea per sentence. We'll look at nominalizations and how to use active voice and active verbs instead of nominalizations. We'll look at meta-discourse and overview sentences, statements of the obvious or unnecessary explanation, unnecessary words and phrases, unnecessary complexity, wordiness, and circumlocution. We'll look at using as well as, has-beens, and inclusion of irrelevant material. And lastly, we'll look at weasel words or equivocation. So let's get started on this lesson. And we'll get started by looking at the first topic. And that is keep sentences short and with one idea. So we already mentioned this concept in an earlier lesson, but it's one that's so important, I thought I would like to bring it back and talk about it specifically again in this final lesson. Let's look at an example of a sentence that is too long and or has more than one idea. The sentence says, plant growth requires a source of nitrogen for the biosynthesis of amino acids, nucleic acids, and other nitrogen-containing biomolecules, and insufficient nitrogen reduces the productivity and quality of crops. So that's clearly two ideas. So one is what the nitrogen is required for, and the second idea is the consequence of insufficient nitrogen. Two ideas. It should be two sentences. And this one is simple because they have this and conjunction, and we can just replace that with a period and make it two sentences, as you see in the revision. So none of the words have changed except that we took out the word and we substituted a period for the comma in that first clause, which becomes a first independent sentence. So that first example was an easy one. Well, let's look at one that's not quite as easy. So here's a sentence that is 45 words long. So it's too long. We need to think about what this sentence means. So let's take a look at it. It says, since the sizes and locations of plant available nutrient pools in soils are often highly variable and conditions for nutrient uptake, which are influenced by drought, oxygen depletion, etc., are rarely optimal during a whole vegetation period, transient nutrient deficiencies must be expected to occur frequently. So the questions I ask myself are, what is the sentence about? And once I figure that out, does the sentence convey the intended idea as the subject of the sentence? So when I start thinking about this sentence and I read it again, I think that the main message to the reader is this part that is underlined and in italics and in parentheses. Transient nutrient deficiencies must be expected to occur frequently. That's really what this sentence is about. So all the rest of the sentence is adding additional information which may or may not be useful or necessary to get the point across. So how would I suggest the authors to revise this sentence? I would move what the sentence is about to the beginning. So that's the topic position of a sentence. I would also break it up. So the first sentence would have the main idea. Short-term nutrient deficiencies are expected to occur frequently. Okay, that's the opening phrase. And I've changed must be to are, and I've changed transient to short term. So I've simplified some of the language. We'll continue reading the sentence. Short-term nutrient deficiencies are expected to occur frequently since the sizes and locations of plant available nutrient pools in soils are often highly variable. So the second part of that sentence is explaining why the nutrient deficiencies are expected to occur frequently. Now I make a second sentence that says, also, nutrient uptake conditions are rarely optimal during a whole life cycle and are influenced by factors such as drought and oxygen depletion. So I changed vegetation period to life cycle, and I don't like that use of etc. in the first sentence. So I don't think scientific writing should use etc. If you're going to have a list of ideas, either make a complete list or indicate that the list is partial with such as. Now we have two sentences. The first one is 23 words, the second one is 20 words. We're meeting our target goal to get to sentences with an average of 22 or fewer words, and we've also got one idea per sentence. Let's take a look at another example of a sentence that has more than one idea. So this 46-word sentence says, among these approaches, target gene editing, in which nucleotide variation is introduced at an appointed site and the target mutations are obtained accurately and efficiently, thereby speeding up the functional identification of target genes and genetic breeding improvement, is an ideal method for artificially inducing mutations. We have a sentence that has two interrupting phrases between the subject and the verb. So the subject is target gene editing and the verb is. Target gene editing is an ideal method. That's what they're trying to tell us. But we have these two phrases. The first one is defining target gene editing, and the second phrase is discussing the benefits of target gene editing. And they're both interrupting between the subject and the verb. And so we have really three different ideas happening in this sentence. One is that target gene editing is an ideal method. And secondly, what is target gene editing? And thirdly, the benefits of target gene editing. Three different ideas. So what I would suggest to these authors is to revise the sentence like this. I would make it three different sentences. And these are going to result in sentence lengths of 14 words, 21 words, and 17 words. Among these approaches, target gene editing is an ideal method for artificially inducing mutations. With target gene editing, nucleotide variation is introduced at an appointed site, and the target mutations are obtained accurately and efficiently. This process speeds up the functional identification of target genes and thereby speeds up genetic breeding improvement. So now we have 3 sentences for the 3 ideas. So each sentence is a lot more concise. Now the next topic we're going to talk about is avoiding nominalizations. Now we've already talked about nominalizations in some ways in earlier lessons. Whenever we talked about abstract nouns, most of the time those abstract nouns were nominalizations. Now I didn't introduce the term during those lessons. I'm introducing the term now, but you'll recognize examples of nominalizations once you see them. But first, let's define what nominalizations are. So nominalizations are nouns that are formed from other parts of speech. Academics love them, so do lawyers, bureaucrats, and business writers. I call them zombie nouns because they cannibalize active verbs, suck the lifeblood from adjectives, and substitute abstract entities for human beings. The proliferation of nominalizations in a discursive formation may be an indication of a tendency towards pomposity and abstraction. This is a quote from Helen Sword in her essay on zombie nouns. Let's look at some examples of nominalizations or zombie nouns in scientific writing. So on this slide you'll see 2 examples and 2 revisions. And you'll see that the nominalizations are underlined and bolded, and other nouns that we can convert to verbs are underlined. So the first sentence says, depletion of KIF4 resulted in a decrease in the amount of condensin 1 on chromosomes, and depletion of condensin 1 caused a reduction in KIF4 levels. So nominalizations often end in the tion suffix, depletion, reduction, and in the second example you'll see foundation, collection, preservation, evaluation, utilization. So what we should do is change depletion to the active verb deplete, or its past tense, depleted. So we have to reorganize the sentence to do this. When KIF4 was depleted, the amount of condensin 1 on chromosomes decreased. And when condensin 1 was depleted, KIF4 levels were lower. So I've changed this to a cause and effect relationship. And instead of talking about a decrease in something, we say something decreased. Second example, this information could lay an empirical foundation for the collection, preservation, evaluation, and utilization of these genetic resources. So we have these nominalizations, which are abstract nouns, but they're formed from verbs: collect, preserve, evaluate, utilize. And utilize should be changed to use in most cases, including this one. So the way I would revise this sentence is, this information could lay an empirical foundation for collecting, preserving, evaluating, and using these genetic resources. Now, foundation is still there. I didn't get rid of that because, again, the goal is not to get rid of all abstract nouns or all nominalizations. Sometimes they are useful. You don't necessarily always need to get rid of passive voice. There are times when the passive voice is preferred. So when would that be? When would you prefer to use a passive voice? One time you would use a passive voice is when the agent is less important relative to the information that you're telling, and you want to de-emphasize the agent. Secondly, you might not know who the agent is. So if I went outside to go to the grocery store and my car is gone, I could say, my car was stolen. I don't know who stole the car. I don't know who the agent is. So I would put my car as the emphasis of the sentence. My car was stolen. Other times the agent is obvious, so you might be able to just leave it out and use passive voice. And other times you might want to be developing a topic and keep the flow of ideas. So you don't want to be putting agents into the sentences in that case. And also you might intentionally introduce some passive sentences into a paragraph just to keep variety in the sentences. So you don't want the topic to be an agent every single sentence in a paragraph. And this is a way you could introduce variety into your writing. Now, of course, as we mentioned in the materials and methods section, passive voice is the norm and it's preferred. So it's totally fine to completely use passive voice all through the materials and methods section. But when you're in the introduction, discussion section, I would recommend most of the time using active voice, but on occasion you could intentionally use passive voice construction as well. All right, so another thing I would recommend that you do to make your writing more concise is to look for statements of the obvious and unnecessary information. So whenever you find statements of the obvious, you can cut those. That's an easy cut. And also irrelevant information. You can cut sentences to entire paragraphs by finding irrelevant information and just taking it out. So this is an easy way to cut text. So just omit obvious material and omit any explanations that you have written that are not necessary. What are some examples of obvious or unnecessary? Well, let's look at a couple. High microbial diversity has been observed in almost all environments that have been examined. Well, you can't observe microbial diversity in environments that have not been examined. So that have been examined is not necessary. So we could just say high microbial diversity has been observed in almost all environments. Now, if there are a lot of environments that have not been observed yet, I think that should be pointed out, but it needs to be done in a different way. A second example is numerous studies on polysaccharides from microorganisms, including bacteria, fungi, and microalgae, have been carried out. That entire sentence is a statement of the obvious. And I think the reason the authors wrote this sentence was just to have something to attach their references to. But I would suggest that you don't write a sentence that's just, that obvious. Attach the references to specific sentences that say something that's more relevant to the conversation. Thirdly, observations in the study reveal distinct variations in the values of physicochemical parameters of the lake throughout the year. Yeah, again, I feel like this is a statement that is completely obvious, and it's just there as a place to place the reference for Table 1. So I would suggest placing the reference for Table 1 in a sentence that has some specific result from Table 1. So the first time you mention some result from Table 1, then you can reference Table 1. But putting a sentence that's just obvious like this, of course there's going to be physical variations in a lake throughout a year. That is really text that doesn't need to be there. Another example of statements of the obvious would be something like this, where there are unnecessary words or phrases. Prior to the start of this project, the XYZ team will draft, submit, and obtain IRB approval for the study. Well, before you get IRB approval, of course, you have to draft the application and you have to submit the application. It's not necessary to say that you're going to draft and submit the application. You just need to say you're going to obtain IRB approval. So you can completely take out those 3 words. And you might say it's only 3 words, but 3 words per sentence over a lot of sentences over a manuscript or a grant proposal adds up to quite a few words. And it can mean the difference between a paragraph on 12 lines or a paragraph on 11 lines. Some other examples of unnecessary words or phrases. Prolonged exposure to elevated temperatures induces conformational changes that affect enzyme 3D structure. That's redundant because conformational changes by definition are changes that affect enzyme 3D structure. So we don't need that phrase. The first part of this sentence can be eliminated based on the results obtained in the present study. Now, anytime you see that, you can basically strike it out and just go directly to the result. Both algorithms improved the accuracy of hyperspectral modeling to varying degrees. A total of 8 classes of algae, just say 8 classes of algae, with varied seasonal distributions were identified as part of the study. Okay, so you don't need to say as part of the study. That's obvious. So we can make this sentence, about half as long as it was. The fourth example here, severe acute respiratory syndrome coronavirus 2, or SARS-CoV-2, is the main cause of coronavirus disease, Well, it's the only cause of coronavirus disease. So we can take out main, which has turned to become an international concern worldwide. So we can take out the turn to. So just say coronavirus disease has become an international concern. And we don't need worldwide either, because international and worldwide mean the same thing. So we can make this sentence 4 words shorter. Now we also want to avoid unnecessary complexity and circumlocution. So circumlocution is talking around the subject. It's being not direct. So not directly going to the heart of the matter, but taking a lot of words to say something that could be said in a few words. So let's look at a couple of examples and revisions to make these sentences more direct and more concise. There have been recent calls for such an integrative approach to include both deterministic and random components in order to enhance its predictive ability. So there's quite a bit in here that we could cut out. What's the point of saying there have been recent calls for such an? Let's just get directly to the integrative approach. Instead of saying people are calling for it to include, let's just say that such an approach could include. So my suggested revision says an integrative approach could include both deterministic and random components to enhance its predictive ability. And I also took out in order. Whenever you say in order to something, most of the time you can take out in order. The second example says, furthermore, to appreciate the quantitative variance in relative abundances of key proteins possessing diverse bioactivity, more specifically, differences between melittin and apimin and between icariopin and allergen were tested as a function of the flowering season and behavioral response, respectively. So I feel like this sentence has more information than is necessary. So these specific proteins that they're comparing, this melittin and apimin and icariopin and allergen, those are going to be shown in the figures or tables. Unless you're pointing out specific differences between them in the results sentence, there's no reason to list them here. So that is circumlocution. Also, the sentence is unnecessarily complex. And so I would suggest simplifying it to this sentence below. Relative abundances of key proteins were measured over the flowering season and by categories of behaviors. So they've got these abstract terms as a function of the flowering season, as a function of behavioral response. So why don't we just make it more direct and say they were measured over the flowering season and by categories of behaviors. So we've made it more concrete, and the sentence is a lot shorter than the original. Another example is, while there are a large body of reports suggesting an association between root mass or root distribution at deeper soil layers and drought tolerance in various crop species, there are also a number of reports on root growth angles that influence the root distribution in deeper soil layers, an important attribute in the capture of adequate water under water stress situation. Okay, so that is a 60-word sentence. So I've underlined some of the phrases that I feel like are unnecessary. And that last part that's in parentheses, I feel like that's a completely separate idea that should be put into another sentence. And so I would suggest taking that out entirely. But how can we rework the first part of this sentence? Instead of saying there are a large body of reports, let's just say several reports. And instead of saying suggesting an association between, I would say suggest that X and Y. And then I change association to associated with. The phrase in various crop species I feel like is not necessary for this sentence because we're already talking about that there are multiple reports. So I think we could just remove that phrase entirely. And then the phrase a number of reports on, well, let's just change that to other reports. And so the revised sentence would still be pretty long. It would still have 33 words, but that's a cut of about half. And so let me read you the revised version. Several reports suggest that root mass or root distribution at deeper soil layers is associated with drought tolerance, and other reports suggest that root growth angles influence root distribution in deeper soil layers. So I do think I've captured all of the same content and information that's in that first sentence, and I've done it in about half as many words. Although, keep in mind, there will be another sentence added to this paragraph for that last phrase. Another tip that I have for you for being concise is to limit your meta discourse and eliminate any overview sentences that you find in your draft. And so we talked about earlier that there are different categories of meta discourse that act as logical connectors to help you interact with your readers. And we called some of those transitions and transition words and transition phrases. Now, I'm not telling you to get rid of your transition words and transition phrases. I want you to keep that. The kind of meta discourse I think you should get rid of is when you are talking about what you're going to talk about. And so sometimes you might see advice for writing that says, tell them what you're going to tell them. Tell them, then tell them what you told them. I think this advice might be useful for certain types of writing, but I don't think you should use that advice for scientific writing because you're going to end up being not concise at all. Adding that kind of meta discourse is really not helpful. And so that would include overview sentences like, in the following section we will discuss X, Y, and Z. Just begin discussing X, Y, Z. So I'll show you a couple examples of some meta discourse or overview text that could be cut. As for physiological iron deficiency root responses, the results showed that while iron-starved plants presented an acidification of the nutrient solution at 72 and 96 hours with respect to iron-sufficient plants, foliar treatments did not present any decrease in the pH of the nutrient solution in the period of time of the experiment. Okay, so this is a 52-word sentence. We'd like to get it down much shorter than that so we can keep our average sentence length in the 17 to 22 or 23 range. And it's got a lot of unnecessary phrases in it, and it has some overview or meta-discourse phrases. So the first phrase that is bolded there, that's basically a meta-discourse phrase. It's telling you what it's going to tell you. So instead, let's just get directly to the point. Also, the phrase that I have with the strike through, the results showed that. If you're going to tell the result, you don't need to tell that that's a result. The reader will know that it's a result. So that's a phrase that is unnecessary because it's obvious. The next phrase that I have underlined there, presented an acidification of, well, we can tell that that's a noun phrase because it's got the of. So let's try to make that into an active verb instead of this nominalization. And then foliar treatments did not present. This is kind of a faulty predication because the treatments are not going to present anything. The treatments will result in changes in what the authors are measuring, but they're not going to present something. And then we have decrease in the pH. So again, this is another noun phrase that we can change into something that's more active. And then I didn't underline it, but period of time is a redundant phrase. So period means time. So we could just say during the period of the experiment or the time of the experiment. Now let's look at a revision of this sentence. And I've taken it from 52 words down to 25 words. So a cut by 27 words. That's pretty substantial. While iron-starved plants acidified the nutrient solution at 72 and 96 hours compared to iron-sufficient plants, foliar-treated plants did not acidify the nutrient solution. So the same information is there. We haven't lost any information, but we've done it in half the number of words. Just by cutting overview phrases, by cutting unnecessary phrases, and by changing from passive nominalizations to active verbs. Now let's talk about as well as. This is a phrase you're going to see a lot in scientific writing. Some writers just love to say as well as. And sometimes it's fine to use this phrase, but I would suggest that you don't use the phrase in place of and. Use and instead of as well as, unless the last item is different from the other ones. So you're going from 3 words down to 1 word when you use and instead of as well as. So let's take a look at some examples where and would be a better choice. Cyanobacteria and associated heterotrophic bacteria hold key roles in carbon as well as nitrogen fixation and cycling. So I have a strike through as well as, and in parentheses. So let's read it again with and. Cyanobacteria and associated heterotrophic bacteria hold key roles in carbon and nitrogen fixation and cycling. So to me, the and is much better than the as well as. So these are 2 types of nutrient cycling that are not that different from each other. I mean, they're totally different cycles, but they are similar in that they are nutrient cycles. So and is a better conjunction in this case. Again, in the second case, and is a better conjunction. So let's look at this sentence. Comprehensive interrogation of neuronal circuits requires acute as well as chronic manipulations of spatially defined subpopulations as well as entire populations dispersed over the brain. So in this example, there are 2 as well as phrases. So if we replace those with and, not only does the sentence flow better, but it's also 4 words shorter. The final example is total RNA was isolated using trizol reagent, invitrogen, from undifferentiated HIPSCs as well as from HIPSC CMs at day 25 of differentiation. So these are 2 HIPSC cell lines. So they're not dissimilar from each other. They are similar. So let's use and instead of as well as. So I mentioned that you could use as well as instead of and in the case where the item that you're comparing in the list is different from the other items. So let's look at an example of an effective use of the term as well as. Ruminants have played a vital role in sustaining and developing many human cultures, as well as being used as draft animals and having religious and status values. Now, I like as well as being used here because it's setting up a contrast. So the first part of the sentence talks about ruminants playing a vital role in sustaining and developing human cultures. So by that, they're referring to things like dairy animals providing milk and butter and cheese. And then they're talking about a completely different use. So that would be as well as being used as draft animals and religious and status values. So I think as well as works well in this particular example. Now the next phrase I would like you to look for is the phrase has been or variations of has been. I want you to avoid the has-beens in scientific writing. Now, I don't mean has-beens in the sense of somebody who is past their peak. When you read scientific writing, over and over, you're going to see people saying X has been shown previously, and those kinds of has-been constructions. So we're going to look for those, and we're going to change them to a different construction, to a simple present tense, state of being situation in most cases. And why is that? It's because in science, when something is published, it is taken to be the current state of knowledge. And so something that is the current state of knowledge, we don't need to talk about in a past tense form. Secondly, when we're saying something has been shown, what we're doing is we're focusing on the process. And what we need to do instead is to focus on the fact. So we don't want to focus on the process of showing something. Something has been shown. We want to focus on what it is that came out of that process. The only time I would recommend that you use a has-been construction is when you're going to dispute that information in the paper that you are writing. So if you're writing a grant proposal, that's going to dispute some current knowledge, something that's been published, but you have found out that that is incorrect, then you can use the has-been sentence construction. Let's look at a few examples so that this information becomes more concrete. Extrusion has been shown to be effective at converting unextractable fractions to extractable fractions. Well, let's just change it to extrusion is effective at converting unextractable fractions to extractable fractions. So this is a lot shorter and it's a lot more direct and it's easier to read. Another example is for a few nutrients like nitrate or phosphate, lateral root formation has been shown to respond to local nutrient availability. So unless the authors are going to dispute this point, they should just state it in the present tense. Lateral root formation responds to local nutrient availability. And then just cite those references that are the source of that knowledge. So let's change it to a present tense. 3 more examples, and once you've seen these examples, I think it'll be easy for you to identify them in the literature and in your own writing. It has been shown that condensin 1 loading to the chromosome is largely regulated by Aurora B. Well, we don't need that whole phrase. It has been shown that. So this one is great because it's an unnecessary phrase and we don't have to rewrite the sentence. We can just delete those 5 words. Secondly, in chronic neuroinflammation, the overly active microglial cells have been identified to be, change that to are. The overly activated microglial cells are the culprits in the progression of neurodegenerative diseases. For the third example, it says, furthermore, it has been shown that 83% of core ring scaffolds present in natural products were absent from commercially available molecules and screening libraries. Well, if you cite a reference for this sentence, you don't need to say it has been shown that. This is, again, an unnecessary phrase that we can just cut. So that's going to be 5 words that are cut from this sentence. How else can you make your text shorter and more concise? Other ways to cut text. And I'm not going to have a lot of examples here, but I think it's going to be clear to you when I just explain what to look for. One thing to look for is irrelevant material. So do you have sentences there that are not necessary for your story, that are not necessary for developing your argument? So irrelevant material is a little bit different than obvious material. Things that are obvious, are things that you just don't need to state, and we looked at examples for that. But things that are irrelevant, it's really hard to find examples that I can show you because the sentences won't necessarily have any problems in them. It's just when you read the paragraph, if you read it without those sentences, it's fine. Or you might have a discussion section which has entire irrelevant paragraphs. I've seen that quite a few times. These could be paragraphs that were the information was already discussed in the introduction or maybe in the results and it's being repeated in the discussion. Or maybe it's speculative information in the discussion that has really nothing to do with any of the figures or tables in that paper. So it's irrelevant material. And you could just cut it out. Or maybe it's going off in a side direction that's tangential to the main topic of what you're writing about, and you could remove those sentences. So look for those. You can sometimes cut a really big percentage of your paper by finding irrelevant material and just deleting it. You can also look for what we call weasel words or equivocation and take those out. So what are these weasel words? Let's look at a quote from Steven Pinker where he talks about weasel words. Another term for weasel words is hedging. So he says, hedging. Academics mindlessly cushion their prose with wads of fluff that imply they are not willing to stand behind what they say. Those include almost, apparently, comparatively, fairly, in part, nearly, partially, predominantly, presumably, rather, relatively, seemingly, so to speak, somewhat, sort of, to a certain degree, to some extent, and the ubiquitous I would argue. Does that mean you would argue for your position if things were different, but are not willing to argue for it now? And so I think you get the point. Those kinds of terms, if you're adding them as qualifiers in your writing, it makes you look as if you're not very confident about what you're saying. And it adds extra text. So you can find those and cut them out. Now, I do realize as scientists, there are times when we have certain levels of uncertainty about the results we presented. And it's important not to minimize those. So I'm not saying you should find and eliminate every single weasel word or equivocation. I'm just saying look at it carefully and decide if it needs to be there or if you can take it out. So this could be a source of cutting text in your scientific writing. All right, that concludes the lesson on being concise. So if you watch this lesson out of order, if you didn't come to this lesson at the end of the course, if you watched it sooner, keep in mind that a lot of the other lessons that came before this one had a lot of tips about making the writing more concise. And so I didn't want to repeat all of those in this lesson. And so this lesson on conciseness has only those tips that did not come up in the previous lessons. So really you have to put all of the lessons in this course together. And when you do that, man, your writing is going to be so good. It's going to be really nice. It's going to be concise, comprehensive, complete. Remember those 8 C's we talked about. And the readability level is going to be high. And, put it into practice as soon as possible. That's the only way that your writing is going to develop, is taking what you learned in these lessons and putting it into practice and really getting good at finding these common problems, recognizing why they're common problems, and knowing how to repair these common problems. And as you do it, I really hope you enjoy it. I hope you enjoyed this course and it was helpful to you. And now and into the future, I wish you happy writing.